Oh, that is the wrong scene. There we go. A little bit better. How's everybody doing this morning? Thanks all for waiting. I got Mike on the meeting here, so I started a little bit later because he is over in California, Silicon Valley, and a fun guest. Got a lot to go over today. I'm probably going to do kind of let him teach you bash scripting, but I want to just say, starting off, some of this you're not going to understand because it is he does stuff with bash that even some things I don't understand. When I say he's a master or a wizard, I do mean that in the sense that a lot of times when I'm looking through his bash scripts, there's things I don't understand. So it's good. Should be a lot of fun going over this, and I'm gonna go ahead and bring him in right now and see if I do this. This is also the very first live chat I've had through the live stream, so we'll see how this works. Mike, how you doing? Yeah, good to see you, man. Oh,
Node.js. So
sorry
hopefully
about
this is
that.
interesting to the crowd.
I actually, yeah, I had you muted for a second just because I had everything going. I got it now.
Okay.
But yeah, no, introduce yourself a little bit, Mike. Kind of tell them who
Okay.
you are and yeah, what it is you do on a daily basis and just some of your expertise.
Okay. So I founded a company called Kubuntu Focus, or one of the founders actually, and we specialize in focus machines specifically designed for business. Our emphasis is on reliability and availability of third-party apps. We do all sorts of things like create NVIDIA drivers to make sure they always work for gaming as well as deep learning and machine learning. We curate the kernel to make sure that it always works for the hardware. So even if things break upstream, we protect people downstream from getting that kernel until we've made sure everything is working. Um, and we also support only LTS releases because a lot of third-party apps don't officially support the interim releases, and we just try to make that better and better over time. And there's a lot of people, space agencies, and that sort of thing that use our hardware and are very pleased with it. And we think it's really the type of solution that really the community needs to make the gap, to fill the gap between a hobbyist type of distribution to an appliance level product that people can rely on in their business. And so we're making a big push in like Silicon Valley, where I've worked for the last 10 years as a senior architect. And we see a real need for that for certain verticals. So I'm the author of single page web applications, JavaScript end to end, back when that was real hot. And I was one of I had a whole bunch of single page applications under my belt before they became cool. And I've scripted for, like I said, lots of organizations. No matter where I've worked, I've always ended up doing automations because they don't have automation departments in startups, especially. And it's something that people really end up relying on a lot. But moving to the Kubuntu Focus, where we're delivering to thousands of people these packages, I had to bump up my game quite a bit because it's one thing if your script breaks down the hall from Bob, but it's another thing when you've got people thousands of miles away that have an issue with a script that has a fringe case, and now you've got to support it. So it kind of all comes back to support cost.
Very cool. Yeah, so how long you been doing bash scripting then?
I've been doing shell scripting since I'm going to date myself here a bit, since the early 90s.
Okay.
right after I got out of school. I had this wonderful experience working for a company called SDRC, where I was a software designer and a consultant for some of the most complex hardware in the world and software in the world that's used to build Boeing planes and automobiles across the world. And so it was a wonderful job. I mean, it was just like sit down and dream up what you're going to do with math to figure out how to represent the most cutting edge designs in the world. And it was really, really cool. I miss it. I wish I was doing that to this day. Loads of fun. Ever since I moved from a DOS-based machine to a Unix-based machine, I was totally in love. It was like, there's a question later on about batch scripting versus shell scripting, and it was just like, at that time, it was just a huge level up. Just felt so powerful and capable, and machines were running RISC, and they were like 6 times faster than a DOS machine at the time. So, like I said, I'm dating myself here, but that was. That's kind of how I got into it. It's always been something that's I've been doing on and off, and I've been coding since I was around 10 years old. So it's kind of, it's like my second language.
Awesome.
Very close second language. So.
Yeah, no, I got, I've met you basically through K-Focus, and then I started looking at a lot of those scripts, and I was just like, I couldn't even understand them because of the level of complexity that was involved in how you design them. So I was like, okay, I'd love to know more. And you actually sat with me for like a good hour or two that one time and just said, hey, this is some of the debug tools I use. This is how I look at shell. And it made me a lot better, or giving a little bit more of a fundamental understanding, even though there's even parts of that where I even got lost in the weeds a little bit. And, I made my own scripts, bash scripts, but they're very rudimentary compared to what you do. And that's why I was like, hey, I'd love to have you on and just kind of have you walk through what bash shell can do and all of the scripting, because I use it, I think, as almost like a middle school level where you're in the pros. And that's where I'm kind of like, hey, I'd love to have you kind of go over what all bash can do, because there's things I didn't even know that you could do GUIs with it. You could do all kinds of craziness with it.
Yeah, you can. This kind of goes to some of the stuff that the questions were like, why bother with bash shell? I mean, why not use Python for everything, et cetera? And the short answer is there are times when bash shell makes sense, and there's a lot of times where it doesn't make sense. And we'll go over the reasons why that's the case. If you look at how you manage any language, once you get to kind of the big boy status where you got to support stuff that's going out to thousands, or in my case, I've had billions of people that are using my software, and the difference between 100, people in an office doing it versus a few thousand versus a million or a billion people that are using your software, it's a whole other ballpark. So we're moving towards the fact that we can support, effectively millions without losing our shirt on the software. And of course, that goes back to quality control and technique, et cetera. It's more expensive, but that's kind of like the whole ethos of what we're doing is, we say we do the hard work so you don't have to. You think about it, when you write your shell scripts, for your kind of a hobbyist kind of approach, you're just trying to get, you're trying to be one and done. And it works for your system. But what happens if you throw in all these other variables, and how do you test those other variables? So I'll show you how you can do that using unit testing with bash shell script, and how you can set up a test harness, kind of all that sort of stuff that it can be useful. And I contacted you about this because I thought, number one, this guy's working his butt off. So he probably could take a little bit of a breather and let me talk for a little while. It might be nice for him.
I love that.
And the second thing is, I saw that you guys are putting together kind of like your own community distribution. And I thought I could give some pointers along that way that might be really helpful for the team that are contributing. Because, if everybody kind of bumps up the game a little bit, like in, shell scripts that they're doing, or any scripts, because these concepts we're talking about can be applied to any of them. They At least the high level concepts. Then it could be really helpful for the stuff that you guys are working on, and so that'd be great. Plus, if somebody wants to help contribute to Ubuntu Focus Code, then I got somebody pre-trained, so that'd be a good thing. So,
Awesome.
But
Well,
no,
cool.
that's not my evil, overspiring goal. I just thought it'd be fun to do this.
Yeah, and when it comes to open source, that's the power of it, is having like probably the coolest thing that's happened is a lot of the commits that happen on any of the projects I do. I'm still relatively new to open source Linux community, and just getting like those GitHub commits, I'm learning something new almost every single time I look at someone else's code or how they might do something. Some of it is done improper, some of it's done proper, and I love seeing more of a professional as they come in how you guys code and design things, because there's going to be things that I might use, like maybe a variable that has spaces in it or something like that, and I didn't put quotes around it, and it can cause all kinds of problems with scripts. And I love to see your take on that, and give kind of a base layer for everyone watching this.
Yeah, the other thing that I thought was really interesting is, and I talked to you about it yesterday. We We've done a deep dive on the stuff that you don't normally think about. But if anybody out there is running Neon, which by the way is a great distro, it's got a different kind of market than what we're looking at. It's maybe a little bit more bleeding edge, which we're not about bleeding for our market. But I love Neon, and we're now collaborating with some members of the Neon project to handle a problem with the way that kernels are being cleaned up in the system. It's kind of an esoteric thing, but if you've ever been bit by it, you don't think it's esoteric. And the biting by it is that the default boot disk is too small, and the kernel cleanup handling is not good. And so what happens is the boot disk fills up, and then it's just a whole world of pain. And so would you rather have that kind of hobbyist feel and have your computer kind of blow up on the day that you launch it because the disk is overfull, or would you rather have just the system be an appliance and take care of itself, at least in that arena? You want to, what we want is we want to have the systems to be an appliance until you don't want them to be an appliance. And then when you're done with being, having fun and stuff like that, I mentioned this before, like in Jammy, we actually are planning on having, fingers crossed, an LVM snapshot rollback button that you just press. And so you could just, come and screw around for a little while, check things out, and then go, you know what, I need to get back to work, press the button. A few seconds later, maybe a reboot, boom, you're back to your nice solid system. It goes right with our ethos. So,
that's cool. So
yeah,
for that, Jammy, that's 2204, right, for Ubuntu?
Right.
So yeah, anytime you say Jammy, I'm thinking that.
Yeah.
Now, when it comes to that, I have to ask: are you going to be using like BetterFS? How are you gonna do that flip back as far as rolling back when something wrong goes? Because I'm thinking like time shift and some other stuff I've used in the past. Yep. But how would you approach like your backups? I mean, I'm just
okay. So our backups are now we started off with time shift. Actually, this was before you got your machine, but the time shift moved in to replace. I'm sorry, not time shift. Back in time replaced time shift because it had better integration and it was more aligned to what we were trying to do as far as ease of use and interface and consistency. When you've got an app that opens up and because of GTK bugs or something like that, it shows a gray text on a white background, that's not acceptable. And so all you can do is either fix that or try to fix it upstream. Or you can look for an alternative. We always try to pick applications that are number one or number two in their group. And so time shift is probably number one, almost certainly.
Mm-hmm.
But I would say that back in time is number two. And there's actually been, we look to make sure that they're not moribund, that they're actually being actively developed or at least actively maintained. And time shift has a good track record and it works great. I mean, I have snapshots running every single hour on my machine. So if I screw something up big time, I can go back and click a button and literally roll back all of my user data to an hour ago, 2 hours ago, or whatever I want.
So are
And
you using BetterFS for that, or are you using different file system?
okay, so that's a different layer. So that the back in time is not file system dependent. That's just an rsync solution.
Mm-hmm.
Now, okay, so speaking about Janus, and that's running today. That comes out of the box. All you got to do
Right.
is click a disk, and that's really nice, man. Like, how many OSs do you get where you can like open up the box, click a button, boom, start taking 1 hour snapshots? That's
Yep.
all pre-configured. Well,
what's the underlying layer there? I imagine you're using like some version of LVM on top of like ext4, or what are you using?
Okay, so what's happening is that you have, I don't want to get the order wrong, but I might here, so I apologize up front. I can look it up. But what we have is the disk partitions are set up with the standard Kubuntu encrypted disk partitions. And we're moving to increase the boot partition from 0.7 gigabytes to 2 gigabytes and we researched all of this. So you don't have to research it. Like for your distro, just steal from us, okay?
Right.
Just take my advice, get a 2 gigabyte partition, okay? And then when we get our kernel manager, we've already got a great kernel manager, which we'll see today. But when we get the ultimate kernel manager, you should definitely be stealing that too, because it's going to be a big step up from what Ubuntu and what we provide. It'll be a good step up from us and a big step up from Ubuntu, and we'll be hooking it into the Ubuntu ecosystem. We want to upstream it. So,
I gotcha.
All right. So getting back to the base file system. So you have like this user space backup, which is back in time. That's doing rsync. Now, what we want to do is we want to get snapshots on the file system level. And you have really three choices for snapshots: ZFS, ButterFS, and LVM. So we did an assessment, and this is, again, who is going to be a hobbyist and spend 2 days or 4 days figuring out which one makes the best sense to use for your distribution, right? Better send that off to somebody who wants to bridge the gap between, hobbyist item to Mac-like or better reliance and capability out of the box. That's what we're trying for. So we did spend days looking at this and actually doing loads on virtual machines and actual hardware. I've got a separate disk in my machine actually here where we're doing separate loads. ButterFS is great, but you can't encrypt it easily. ZFS is great, but it's not supported in standard. So if like somebody needs to reload their OS, we've got to create, and we already do create our own ISO to help provide these sort of features, but it's a lot messier sort of thing. The LVM is already the default setup, and LVM provides snapshots. So we're working through taking the snapshots. The snapshots are instantaneous. We've got to work through some stuff like making sure that user data is not added in the snapshots, because you can imagine if you do an LVM snapshot and then you pull down like a Steam game and you put 30 gigabytes on your disk, well, your snapshot just grew from 0 bytes to 30 gigabytes. And we don't want to have 30 gigabyte partitions. So we're looking at, partitioning it a little bit differently, keeping home data separate so that you can easily wipe and reload your stuff, but having it fully encrypted the entire time. There are some challenges there with the boot partition, which is not encrypted, and you want to be able to roll that back as well. And we're working through that.
Now, you did say you're working with, now primarily you're Kubuntu based when you're working in this stuff, but you did
Right.
just say you were working a little bit with Neon, KDE Neon, as well.
We
I,
work with we work with Neon.
uh-huh.
We're working now with Neon a bit. We've had some feelers out there for a little bit, and we're working
Yeah.
with a guy from Neon, and they showed us what they were doing for the kernel cleanup originally, and they were very early in it, and so I saw what they were doing very early, and I'm like, whoa, we're like way far ahead of this. So let's
Uh-huh.
reach out to them.
You kind of just shared with what they had going. One
Right.
thing I have to ask on Neon, just kind of get your,
Yep.
the first thing that pops in my head, the only thing I didn't like about Neon was there was apt, but then they had like another package manager to manage, I think, the KDE packages on top of apt, which was, I thought
Yeah.
was kind of interesting. And I
Pecan.
just, what's your take on that?
I can't follow everything.
Hmm.
I do know that they used, if I recall correctly, it was Pecan.
Hmm.
And you know, uh, I just think that Neon is a different niche. Neon is for the people that want cutting edge software all the time, especially KDE.
Hmm.
And uh, it's on a solid Ubuntu LTS base, and that's great. But the cutting edge software, cutting edge, bleeding edge is where you bleed. So there's
Well
actually
said.
another problem with that. I mean, there's been a lot of folks, especially in the Linux community, that are hobbyists and they want always the bleeding edge software, and that's great. Um, I have bleeding edge software all over. We run multiple distributions constantly because we have other people that are working on the Ubuntu Studio team, upstream projects, etc. So we're testing out new kernels, we're doing new OSs, we're doing the interim releases, we're following all that sort of stuff. But when we're done doing that, we go and we switch back to the Kubuntu Focus distro. And I think this is actually a problem in the Linux distribution environment, which is the emphasis on always pushing forward as fast as possible and not cleaning up behind you is really, uh, to a large extent, the root problem with getting third-party apps on Linux distros. I mean, you think about it. Windows comes out with a new OS once every 4 years, once every 6 years.
Well, I mean, they did say Windows 10 was supposed to be the last
Right,
OS,
right.
but
But
but yeah, no, it is a consistent experience.
you got a stable platform to build on,
Hmm.
and it's like trying to build, to use the parable of the Bible. You don't want to build your house on shifting sand.
Hmm.
And there are so many applications that used to be great on Linux that you can't even run anymore.
Hmm. I've run into
And
that.
even stuff that ties in with KDE. I mean, I love KDE. I think it's a fantastic desktop environment, and I think they're actually doing something about this. But if you look at what we've got in the Kubuntu Focus, which is on 22.04, we've got the 5.14 kernel right now. I mean, that's only a couple steps away from the absolute cutting edge kernel that you can get, right? I
Hmm.
mean, we're running at 5.15, 5.16 right now. 5.17 if you really want to bleed. So you're not really giving up that much. I mean, we do have an older version of KDE, but it's solidified. It's got bug fixes. It's got extensions that we've added where things are missing, etc.
Hmm.
And it's reliable. Whereas you switch over to something that's more of a more bleeding edge, you're going to bleed on that. So
I see. So I switch back and forth between some of the
yeah,
really bleeding edge portions, like
yeah,
Arch
yeah,
is a good one. That's like, hey, it can't get much more bleeding edge than that.
right,
And then
yeah,
also like Debian, but also I've cut my teeth when I was learning Linux. It was all in CentOS 7 and
yeah.
RHEL-based systems, which are
Me too.
about as stable as you can possibly get in a
Yeah,
professional environment, in server environment.
yeah,
The last thing you want is your server being bleeding edge. So
yeah,
I understand that aspect, but I also understand like a lot of people always ask about Linux adoption and using Windows instead of Linux, which you kind of brought up, how Windows just, it's there for not much changes really. And
Right.
also the kernels work a little bit different in how it does its driver design. The problem you have when you get these really stable distros, like RHEL-based distros, like
Yeah.
CentOS 7 was a good example, or
Yeah.
Rocky, Alma Limit, Linux, all that's RHEL-based.
Mhm.
None of the new hardware works on it, at least not properly when it comes to a lot of that type of thing. So there's this balancing act that needs to happen for newer hardware in Linux, that it's able to evolve with it as it
Yeah.
gains more of a desktop following. And that's like, I guess that it's a weird thing that where sometimes I'm like, Arch, because I have something that just came out last week.
Mhm.
And other times I'm like, okay, Debian's fine for this, as it's like maybe 6 months behind. And that hardware is not that new, so it's fine. But it's kind of weird. I guess that's the structure of like kernel design, like monolithic and all that, between the two, Windows and Linux. But
Well, I think what you're running into there is summarized in 3 letters: AMD. And I'm not saying it's a bad thing, but I think it's growing pains associating with getting AMD integrated into the open source stack. There's still lingering pain around that.
Mhm.
And people complain a lot about NVIDIA drivers, and there are plenty of things to complain about with that. We spend insane amount of hours making sure NVIDIA drivers work and continue to work, and that we pull down all the right ML libraries and that sort of stuff. And we do pinnings. We do.
Mhm.
You don't want to know how the sausage is made. But that being said, NVIDIA has had a stable and mostly trouble-free, at least graphics driver for 15 years on Linux.
Mhm.
And you may not like the way they did it, but they did do it, and they've been using it in industry for people who are running Maya, and for people who are running Lightworks or DaVinci Resolve, CAD CAM, oil and gas exploration. These are people that can't allow things to fail, or they're down for days for people that they pay $1,000 a day to do this work. So it's unacceptable. Now, Intel has been integrated on the open source stack for about as long, or if not even longer, and the Intel stuff just works. We're thinking about coming out with an Alder Lake NUC, a nice low-cost Alder Lake NUC. And the reason why we're thinking about Alder Lake is because the performance is competitive, the pricing is good, and most importantly, that open source stack is very mature. Whereas there's still pain, there's still people using pulls from GitHub repositories to compile, Git plus 7 or whatever in order to be able to get their new AMD hardware to run. So
I gotta commit. I am Team Red 100%. Like I love AMD all the way. That's what I use for pretty much all of my desktop PCs here. And when it works and you have everything up to date, it's fantastic. But I will say, to kind of clarify, you said AMD sometimes doesn't work all that well on Linux. And just to share a little tidbit for me, I didn't have my BIOS up to date, so I was getting like a lot of IRQ errors and some things like that. So when you're saying that, I know a lot of the desktop or hobbyist realm, specifically, they love AMD much like me, because I kind of fall into that same niche.
Right.
And that's why on some Linux boxes, you typically in business, I always am running, Xeon or Intel hardware, because it's so proven. But at the same time, for my home desktop use, for gaming, whatever it might be, I still love AMD because of when Ryzen came out. That's kind of when I was like, hey, this is actually a pretty good value. But I have seen some growing pains there, so I can relate to that.
we're looking at a low cost NUC with an Alder Lake, and Alder Lake's got really improved
Hmm.
integrated graphics. It's basically got I think it's got the 96 EU core, at least on some of the SKUs. We have to look into it more. This is this is not highly researched, but so imagine an Alder Lake that is runs on a little box about the size of a quarter of the size of a shoebox, or the size of three CD cases stacked on top of each other. That just screams and does pretty much everything you want, even low level gaming.
Yeah.
For I don't know what the price point will be, but maybe $400 or $500, maybe $600. That would be, I think, really compelling.
Yeah, I've dealt with a lot of Nook stuff, and it's
Yeah.
fun for like I'm thinking like home theater PCs and some
Mhm.
little tiny workstation portions. I still I used to be a fan of the Nook design, but I've used them long enough now since their inception that
Mhm.
whenever you pack so much stuff into a tiny area, its lifespan is just not as great as a traditional desktop, I would say.
Yeah. Yeah.
And
I'd like to
that's
get
the
something.
one downside to it. Usually, and most people are cycling them out 3 to 5 years, and it's fine. But I have desktops. My wife's computer, by chance, is 10 years old. I
Mhm.
mean, it's
Yeah.
it's pretty old, and
Yeah.
you just wouldn't get that with when you have those compact,
Yeah.
those
Yeah.
super mini PCs. But I mean, still cool to get
Yeah.
those for a lot of use cases.
And the reason why I brought up the whole point about doing an Alder Lake instead of doing an AMD, we'd like to do an AMD, but the thing is that for our ethos, for what we're looking for with our verticals in our market, the AMD open source stack just isn't quite there yet. When they
Mhm.
get to where Intel is, then it's open season. But I'm seeing some competitors that are bringing up AMDs because they know that their customers, their hobbyist customers, really want it. I mean,
Uh-huh.
there's a new 5800X mobile device that came out recently. And I looked at it, and it's got a 49 watt hour battery, right? So how long is that going to last?
Uh-huh.
And the 5900X, actually 5800HX, is actually less performant than an 1180 11800 device
Yeah.
as well. So
AMD's always struggled in the mobile section.
yeah,
I can't think of a time where they've outperformed a lot of Intel devices in the mobile sector. But then
and the
again,
other
I'm not a big laptop guy. I've always been like, give me a desktop. That's where the power is.
and again, don't quote me on this, but from what my research has shown is that the AMD does much better on a per core efficiency basis. So like if you're running
Hmm.
extremely threaded cores, if you're running Geekbench in a loop, you're assuming your batteries are the same size, although most devices don't have 49 watt hour batteries with the 1580X in it. It's got a 73 watt hour battery or so.
Yeah.
So, but so if you run that thing in a Geekbench loop, it's going to have better efficiency when it's being loaded. But then the problem comes in with idle power draw. So with Intel, I think that they do better with their power management on Intel on power, like the machine you bought that has an idle power draw of below 6 watts
Uh-huh.
when it's doing nothing.
So
And
what's your take on like the future of ARM going right into that? Like what you see what Apple's done. Like
mhm,
those new
yeah,
Apple laptops, amazing. Some aspects of like Chromebook and their power management also amazing.
yep.
Um, kind of like what do you think that's going to be here in a couple of years? Do you think we're going to see an ARM based Linux box or Linux laptop?
We have connections inside of NVIDIA. They're not the it's I'm not talking to Jensen or anything
Hmm.
like that. At least not recently. Wink, wink. Um, so, but we have actually reached out to see if we can use the Orin processor for a NUC. So, and actually, I'm a Jetson boy from many years ago. So I did Linux on the Jetson TK1 on the development board.
Yeah. I got
And
a Jetson Nano right over there that I'm using for a
yeah,
retro Pi.
and they kick, man. They
Oh
are
yeah.
extremely performant.
Yeah.
And the only thing that prevented us from, or prevented me from using it as a full desktop, even, I mean, and we did in a pinch, was that the it was the compatibility with x86 third party products that was the problem. And
Hmm.
you can compile some of that away, but some of it you just can't compile. So
Hmm.
um, uh, so yeah, you kind of like, you can't use Chrome. You could use Chromium, and then you could hack Chromium to be more Chrome-like, in the good ways, not the bad ways. But still, you couldn't get all the features in Chrome in it, and then that just kept getting repeated and repeated and repeated. You want to play games, boom, you're in trouble here. You want to do this, but from a performance standpoint, and especially from an efficiency standpoint, it was absolutely fantastic. Now, the thing is that, and the reason behind that, I think, that you've seen from Intel over and over and over again, they've been trying to do mobile chips with x86 or AMD 64 instruction sets. And I think here's the dirty little secret. I've been using RISC since the, I'm going to date myself here, but back when I was using Silicon Graphics and HP and Spark machines and AIX machines, back in large installations. By the way, I used to run a couple different clusters as an engineering manager with over 100 different servers for advertising platforms. So with Red Hat Enterprise Linux, go figure. I'm Red Hat certified from a long time ago. But in any event, yeah, when they, around 2005, with the advent of the core architecture, Intel went CISC. All microarchitectures, I'm sorry, are RISC.
Uh-huh.
All market architectures are RISC. So in other words, you might have like a CISC looking front end on things, but behind the music, so to speak, it is all RISC. The architecture, uh, Intel gave up. Pentium 4 was the last full CISC design, at least in the consumer market. And that CISC had such a deep pipeline and required so many optimizations, and had such big expenses for cache hits or for predictive branch hits, that they're like, this thing's nuts. They ended up having to actually go back to a Pentium 3 and move that forward for their mobile platform. They had a Pentium 4 mobile branded chip that was actually a Pentium 3 because it had a shorter pipeline and it was more power efficient. So everything's moved to RISC on the back end, and it has been that way since the mid 2000s, and everybody else was doing RISC. If you bought a top end Unix machine that was 5 times faster than a DOS machine years ago, that machine was all RISC,
Hmm.
64-bit RISC. So what does that mean moving forward? You got ARM, you've got MIPS, which actually, interestingly enough, was spun off from Silicon Graphics. And you have x86 or AMD 64. I'll just say x86 just for safety. So which one's going to win? Well, MIPS has the benefit of being more open. ARM has a nice place in the market, and they got long-term contracts with Apple and the like, and they've got a lot of research and development that keeps getting fed back into their IP. So that's good, and it looks like NVIDIA's bid for them is going to drop through. So I guess a lot of people are going to celebrate that, although I have mixed feelings about that personally. And then you got x86. So MIPS, open source, can be a community thing. And when I say community, I mean businesses working together to make the platform better. I think ultimately that is a very compelling environment, and may actually end up having MIPS win if it has some technical wins and people do actually collaborate. ARM, it's got a great entrenched position, and they can buy their way out of anything with all the money rolling in. So they'll be a competitor for a long time, even if they eventually get subsumed by MIPS. But It's kind of like what you said about with Microsoft. If MIPS gets that big, ARM will buy them.
Yeah.
Then x86. Now, my understanding, and again, not an expert here, my understanding is that encoder, that CISC encoder in front of the RISC front end, causes some real problems, especially with parallelism and potentially power use. Because basically, you have to take these CISC commands in, and you got to swap them around and reorder things in order to make that back end work. And this is about the depth of my understanding on it. So what I can see actually with Intel, if they're going to be smart about this thing, and I just thought this up last night. I'm kidding. I thought this up a while ago, but what I could see them doing, if they actually want to play in the same area, is they take their RISC, their actual RISC front end, for lack of a better term, their RISC API,
Yeah.
and expose that and allow developers to do one of two things. I'm running in compatibility mode. Now my CISC decoder front end is still there. It's still drawing power, but you got compatibility. So you've got basically like the Rosetta Stone overhead. But now we want to compete with Apple on performance and performance per watt. We'll give you another mode where we turn off that decoder and we'll let you go directly to the RISC architecture. So that's what I'm thinking they may consider doing, because I don't see any other way out of it unless they figure out some way to make, and maybe they already have, but I doubt it. No matter how you slice the onion, you're still doing a conversion from a CISC architecture and then having to split that out into multiple steps into a short pipeline RISC architecture. And so that can get really messy. And again, what I understand is that like after 4 cores, you start getting diminishing returns because of the complexity of doing that well for distributing it. I know Intel does 20 core processors and stuff like that, but I think that that those probably rely on simpler issues or a simpler divvying up of the code between those cores. And if you want transparent divvying up, which is what the CISC front end is supposed to do, I think in some cases, then you got diminishing returns in that case. So
very cool.
I'm not an expert on it. These are just some thoughts based upon little tidbits I picked up here.
Yeah, I mean that's cool. Like I'm not a big hardware guy. I've always been software based for the most part. Yeah. So it's good to hear this type of thing, because I think right now the general opinion or the consensus among most people is, hey, Apple's just killing it with their ARM right now. It's much more power efficient. It's just very, very good. So many people have actually switched over to Mac of all things because of how good they've done with the M1 chip, and kind of seeing, hey, what's going to be the response on these other architectures to compete with this new challenger that emerged basically out of nowhere.
Well, and I think one of the things that we have to give credit for some of the power efficiency. First of all, I mean, they've done a fantastic job of buying a lot of talent from that are silicon, innovators, and they also had I'm trying to remember his name, Jim Kelly, from AMD 64 fame. I may be misremembering his name. But on the team for quite a while, and so they bought a bunch of talent, and so there's a lot of credit to be given to those people, and they've done a fantastic job of bringing a true RISC-based architecture forward here. And it's what workstations were doing 30 years ago. People knew it was the right thing to do, and you got fantastic performance on PA RISC and Silicon Graphics, and MIPS came from Silicon Graphics. Well, MIPS was purchased by Silicon Graphics and used by them exclusively until they spun it off. So it's kind of like what's old is new again. It's kind of like rapid development versus 3D printing. They're the same thing. It's just 30 years later. So yeah, it's exciting to see that progress. So
Well, cool. Well, all right, man. Well, you want to get into some Bash scripting now that we've kind of
yeah,
got some chat going on, because I know you have a lot to go through here that you sent me prior to this video, and I know we could just sit here and chat all day long, but I'm
Did you
sure
want to
some
go over
folks.
some of? We had a couple other questions. Do you want to go over a few of the other ones? Because
Oh yeah.
yeah, I wrote
Let's
down a
hit
few of
that
the
up.
notes. Sorry about
Oh
notes
no.
right there. I'm not
Yeah,
lying.
there's some for anybody in the audience. I asked the community, hey, what would you like to ask? And I wanted to go through one. The first one that jumps out, since we were just kind of talking about ARM, Apple, and all that,
Yep.
and kind of the theme of all this, because you're really good with Bash scripting, is why did Apple move away from Bash? Because I thought that this was probably one of the most interesting things, and move to ZSH is, and I think some people in the audience are probably thinking ZSH must be superior if Apple chose it over Bash. And what's your response to that?
Well, I don't want to disparage ZSH. It may be a fantastic shell, but Apple moved over for one reason: licensing. Bash on Apple up till recently was 10 years old. They were
Mm-hmm.
using a version 3 because in version 4, Bash moved to GPL 3, and that's poison to Apple. So you don't have to. I mean, lawyers are running Apple in a lot of ways. I mean, like I do is look at their webpage and look how many footnotes they have on their sales. I mean, they have these outrageous claims on their website, and then they got footnotes on every single outrageous claim saying, okay, well, we tested this against a PowerPC 1998 Mac, right? And that's how we got the 500% performance. But it's all, it's like you feel like you're signing up for a 15-page terms of service just reading their marketing material.
I mean,
So,
that's almost every tech company these days, in a lot of
well,
ways. Unless when you get out of the Linux realm, I should say.
yeah. Well, on our homepage, we actually have like 8 different footnotes that actually do describe that,
Mhm.
because I think that really is. I mean, you don't want to hear something's 5 times faster and then 5 times faster than what, right?
Yeah.
So
Yeah.
it's good to. So I like some aspects of it. Some of the aspects that I think is
Yeah, I looked over the
entertaining,
the
right?
marketing material on some of that stuff, and like
Yeah.
the graphs have no keys or legends, and it's just like lines
Right,
drawn.
yeah.
I'm like, what are you guys doing?
NVIDIA.
But it's
Yeah.
funny. It's
I
funny.
like NVIDIA. NVIDIA starts a graph, like the graph goes from 800 to 900.
Yeah.
Right. So it looks like, you went from 0 to like 10,000%.
Yeah,
Actually,
everybody's guilty of that, especially in the performance realm. It's always
Yeah.
funny to see.
yeah.
But that was a good one, and we already talked a little bit about the differences between shells. A lot of the audience is Windows based. What are your thoughts on, like, have you had much interaction with like PowerShell or WSL and that type of things in Windows environment, or do you even use Windows? Is maybe a
I don't
question.
use Windows. I haven't for many, 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 many years. I did used to have a Windows laptop, and it always frustrated the hell out of me because I just, I want to open up a terminal and control it, and you can never do that with Windows because they were having a pure GUI operating system, which we
Mhm.
all know how well that worked when they were doing Hotmail. So,
Oh yeah.
in fact, I actually made a note. PowerShell, I believe, had its origin. If it wasn't actually started because of Hotmail, it was certainly sparked by the Hotmail issues. And
Hmm.
for the people out there in the audience who are too young to remember this, which probably half your audience may fall into this category, Microsoft bought Hotmail and they couldn't make it work with their servers. And they couldn't make it work with their servers because they couldn't script the goddamn things. Excuse my French. I told myself I wasn't going to swear. So,
That's okay. I don't
yeah,
care.
so I'm not going to swear from now on. So I'm going to try to anyway. And so they had this. There was an internal like memo about why they couldn't do this. They tried like 5 different times, but one of the key problems was that with the free BSD, they could just script the things to build. And this is what we did. And we'd used it, for the clusters that I ran starting at around 2005. I mean, we could just spin up a server. We were running on real hardware at the time, and we would just spin up a Red Hat server in 2 minutes, and then boom. So we need more power, baby. We would just just repartition an actual physical machine, or if we had like one product that needed more servers and one that needed less, we just shift between the two of them. It'd take us 2 minutes. And they couldn't do that. I mean, they're like, loading the CDs into their servers apparently, and going, okay, well, let's see what driver comes next. I think I'm going to gamble on the GPU driver now, right? So it was like they're doing that for these production systems, and apparently they were doing that for the London Stock Exchange, which ran on Windows NT until the promotional payments from Microsoft stopped, and they quickly went back to Linux. I think that the Power Bash was inspired by that. I'm sorry, PowerShell. From my understanding with PowerShell is a very worthy competitor to Bash. It has a lot of the same capabilities, and it is more consistent in a lot of ways, and has basically a lot of benefits from being reconsidered over the years. Although, on the other hand, I believe that they've missed some of the compelling elements of Bash because they weren't necessarily living in it as much, or they weren't using it in a way. So I think that from a power standpoint, it's pretty much a wash, and that let's say batch scripting is nowhere near. I mean, I did batch scripting again many years ago. Maybe it's all improved, but at that point, batch programs were, they were they were oatmeal and corn shell and Bourne shell on Unix were a whole programming environment, and which you'll see today. It's outside of I don't suggest you use Bash shell scripting for incredibly complex programs or things that need arbitrarily complex data structures. There are better tools for that, but for automations that or things that need to be in Bash, which we'll discuss later, I mean, they do make it makes a lot of sense. And also, it's really accessible, because if you're doing it on your shell, and your shell is Bash, and you've gotten good at doing aspects of it, you just type in history and go and cut and paste your history into a file, and boom, you've got an automation. So for a quick hack, it's really compelling. And then the question is, how do you grow it up from there? And when do you decide to say, okay, you know what, this is getting so big and complex that it's time for me to consider a different language?
Yeah, no, I cut my teeth. I'm actually was more into the Windows Server realm. Actually, the first certification I ever got was Windows Server 2000, and then 2003 SBS, and I actually transitioned a lot into PowerShell scripting before I even touched Bash. And it's kind of interesting. So I'm coming from the other end of the ways, and I'd say the syntax of Bash is so nice because it makes sense. And if you ever done any PowerShell scripting, you realize real fast some of the syntax, you're just like, what were they thinking? But it's kind of funny, like, not to get too off in the weeds here, but Windows has actually done like Windows Server Core and removed the GUI, and kind of removed it. Semi removed. It has just like the command prompt to where you interface and you use your workstation with like RSAT loaded to control the servers. And that's kind of like my area of expertise that I really never get to talk about or even kind of show, because it's such a niche thing that most people are like, whatever. But that's cool. It's cool to see both ends of the spectrums kind of in regards to, the shell and how you interact with it.
And I think what Microsoft has done, and they basically ceded the server market to Linux. I mean, MS SQL is now on Linux. By some reports, the majority of all servers, and certainly all big iron servers on Azure, are running Linux. Linux as a server operating system is absolutely fantastic. I mean, it's you don't have any licensing restrictions. You add what you need, you remove what you don't. You've got staff that's dedicated to optimizing it. You don't have a bleeding edge rolling distribution that's breaking shit all the time. It's crowdsourced by a lot of people that are making money off of it. So it's only going to get better. They've seeded that. What they've recognized that their cash cow is gaming and client computing, and keeping that closed ecosystem by staying in cahoots with people, especially like Adobe,
Uh-huh.
to ensure that their applications only run on their OS and remain that de facto standard. So there's a reason why all of our Microsoft French fries are being grown on Bill Gates' land, across the. And it's true.
Fun fact: Bill Gates
Yeah,
is like one of the largest landowners in the farm landowners in the United
yeah,
States now.
yeah,
Which I was like,
yeah. Bill Gates
but
he owns Idaho now.
yeah,
And that it's
oh,
because he's got the de facto standard in the desktop realm, and
mhm,
there's a reason why they're buying these gaming things, is because they've recognized what their future is. They've got they co-opted Linux for profit on the back end, and they've
mhm,
used their capital to buy. Like you said, they're just going to buy Linux. They went, oh, servers are Linux, let's buy it. They
mhm.
did. So they're now competing successfully against Amazon, because nobody ever got fired for choosing Microsoft. And so we're going to go to Azure, and they also have tools to migrate from the legacy Exchange servers to their cloud tools. So
Mhm.
it's just I don't want to be too judgmental about that, but
No, I've done a lot of
money begets money.
migrations on that, and I
Yeah.
mean, for the most part, the world still runs Exchange. They say that's probably one of their biggest platforms where they've still been able to dominate in the business realm. Specifically, was mail, and I've
Mhm.
done so many on-prem to O365 cloud conversions that it is, you know, and it just works. I mean, I get it, but yeah. Yeah,
Yeah.
it's wild to see that take over. But what are your thoughts on like how do they? Adobe's also with Mac, and do you think Adobe will ever come to Linux, or maybe Microsoft will make Microsoft Office for Linux? What do you think? Those are like the two biggest programs I think that
Yeah.
hold back Linux. A lot of people from using Linux as a desktop.
There's nothing preventing them from doing it right now.
Hmm.
They could do it with pretty good performance using, say, our favorite Snap, Flatpak, or App Image. But
Yeah.
I mean, you could just get a containerization, and you would get excellent performance across. Well, I should say, good performance across. And once, let's face it, all those solutions have memory issues, but they're not that big. And then they have performance issues, but those are typically relegated to startup times.
Hmm.
But after that, I mean, you could have actually a pretty damn good, or like almost indistinguishable benefit of having those things on the Linux desktop.
Yeah.
Um, they're not going to do it, because what that does is it breaks open the floodgates for people to unchain themselves from the closed ecosystems. So, uh, yeah, I mean, it's like, why does iOS have green bubbles versus blue bubbles in iMessage? Why do they keep screwing up messages coming from Android users, and oh, we accidentally dropped them? um, you know, they're not incentivized to make it. I mean, they're not incentivized to make it work. In
Right.
fact, they're de-incentivized to it. I've heard that there's a lot of teenagers in the United States. I found sales to teenagers is enormous, because I found teenagers just want appliances. They want something to run
Yep.
Tinder. They got other things on their mind. And there is enormous social pressure for everybody else to use an iPhone.
Hmm.
And Tim Cook is just, he's got to be like going to the gym every morning and just, slapping people on the behind and going, hey, man, check it out. I got another 3 percentage point in the 16 to 24-year-old group, because
Hmm.
our iMessage still sucks with Android. I mean, it's perverse market economics. And until there's some sort of, I'm not like a big fan of government regulation, but a regulated economy makes a lot of sense, and in a lot of cases. And until there's something that says, okay, you have to interoperate, and we do have laws around that.
Right. I
Yeah,
mean, but you look
yeah,
at the cell phone market right now, and you have
yeah,
Apple and you
yeah,
have Google. I mean,
yeah,
really, when you break down most technology, it all filters back to those big five that control pretty much everything.
yep,
And there's very little outcomes. And speaking of the younger, generation, I think back when I was a teenager, And a lot of people don't realize a lot of the magic of technology back then was getting that device and then not having it work, and you had to tinker around to get it to do what you wanted, to where now you pick up an appliance, you hit one button, and it just works. And
Yeah.
uh,
Well,
maybe
look
it's
at look at
rose-colored
how
glasses,
guys
but
look at
yeah,
how guys defined themselves when we were growing up. I mean, if I can sound a little bit, male centric here, but you know, people who are tinkerers, let's put it that way. There's some
yeah,
girls who love to tinker too, but the tinker sorts, okay? Tinker sorts, when I was very young, were tinkering on cars. The guys got together and they souped up their goat, okay?
right,
Their Pontiac GTO or the goat. And then later on, things got a little more technological. People would still work on their goat, but the other thing that guys really kind of measured themselves up against was how good their stereo system is, or their audio, or their instruments and stuff like that. And people still do that somewhat, and people do all these somewhat. But
yeah,
then when we moved on from that, then people started talking about, okay, well, then the car kind of got replaced by computers, programming, building your own computers, overclocking, stuff like that. I think that age is actually starting to go away,
mm-hmm.
and that age is being replaced. And I'm really sad to say this. I've got a couple teenage boys.
I have an
And
18-year-old too,
yeah,
so
yeah. So it's been replaced by gaming
yeah,
and loot boxes and this whole gaming subculture thing. And it's like, you know what? I kind of wish that there is, at least back when you were building your computers and stuff like that, you were learning something that was a life skill.
yeah.
My son wants to be a professional gamer. Um,
Be a professional YouTuber or Twitch stream star.
yeah,
Uh,
yeah. So, so the way that people have measured themselves has evolved, and the
yeah,
challenge is, I keep saying the word appliance here, but the appliance thing, even for us people who've gone through all those different phases of tinkering, the appliance thing is fantastic when you just want to get work done. And it's best when you can go in and turn on the appliance when you need it, like that LVM rollback, like I said, and
yep,
then turn it back off again. And so we're working really hard to provide that. We think we already beat like Apple a lot of times in the out of the box experience and the developer experience and the data scientist experience. Um, you know, the setup time is like nothing compared to that, and we don't have to install GNU utils and swap out the shell and deal with all that muck, and try to convert scripts from Mac. I've spent thousands of hours converting Mac scripts to Bash scripts, to Linux compatible scripts, because the developers were all using Macs.
so
And
I gotta ask, now that
yeah,
you've mentioned this, like evolution to gaming and
yep.
making things into Linux, what is your take on the state of gaming and Linux, and what do you think that future looks like? Because a lot of people have hyped up the Steam Deck and that software and how that's going to work, and that's going to draw more people into from the gaming aspect into Linux. What are your thoughts?
Well, first of all, I want to mention one thing that about appliance, and then I'll get right back
Sure,
to your
sure.
point, because they're kind of signed. One of the things that we're also looking at from an appliance standpoint is, for our machines, we'll actually lock the system disks to be read only,
Mm-hmm.
and then when you install packages, it'll be unlocked. Packages will be installed, and then it'll lock again. Now, that doesn't mean it'll be locked like you won't be able to unlock it yourself, but it'll prevent accidental harm to your system
Yep.
without you actually knowing what you're doing.
And that's exactly what SteamOS is doing. I think that's the mutable file system, right? Yeah. And
Um, I don't know exactly how they're implementing it, but
uh-huh.
yeah, that's what it reminded me of, was that very
Hmm.
thing. So it's actually, and while you're building your OS, talk to me. I can
Yeah.
show you how you can set that up, actually rather easily. But we're going to be doing days and days, potentially weeks of testing with this whole solution, and that's going to play a part into it. So we'll get a feel for how realistic that is.
Yeah.
Um,
My whole thing is I honestly I like to break things. So a lot of times I probably won't be a fan of immutable. I'm gonna be like, okay, How do I make it rewrite all the time so I can break it? And that's kind of like where I'm at, because I love breaking and then fixing it. So that's just who I am.
You go into the Ubuntu tools menu and you say, you click a button and the tool pops up and says, what mode you want to run in. And you're like, you pick a mode that says unlock. And now you're unlocked. And then you go and you click it again and you say lock. So, and then you realize you screwed the whole thing up. So you click the rollback button. and then you're awesome. Back. Like you can come in 2 hours early, screw around with your system, totally hose it up, then come back in and click a rollback button after that. And then boom, everything is all locked up again and you're able to do your work and you're not surprised by, the fact that Zoom won't start.
Yeah.
Or, so that's where we want to be. We want to be to the point where you can have the appliance when you want it, and you can have the hacker station when you want it, and then you can figure out what to move back into your appliance once you've messed around with it and more of that sandbox. Now, obviously, you could do that with a virtual box, but it's a different sort of thing. I mean, you're trying to get stuff deployed to your machine, so that's a good mix. So back to the Steam Deck and what that means. Actually, the Steam Deck is, I wish Microsoft hadn't, Microsoft is like such an back when they were being pursued for antitrust violations, they were much smaller than they are today.
Yeah, it's $1.8 trillion company now. That's a lot. Yeah, 1.8 trillion. They could buy Sony, which is a 136 billion. That's how big Microsoft is compared to a Sony, just to put it in perspective.
Yeah, it's absolutely nuts.
Yeah.
The value of Microsoft is more than I don't know what the number is, but it's probably the majority of the world's nations.
Yeah.
So,
same with Apple. Apple's actually more. I think they're up to almost 3 trillion now.
Yeah.
Just to put it in perspective.
They're just up to money machine. That closed ecosystem is just, I have so many friends that are they're using Apple. God, I don't want to spend $4,500 on a MacBook Pro, but I don't have any choice.
I've been good. I spent $800 on the Mac Mini to do Final Cut, and then I was like, oh, I want to get the MacBook Pro, and then I pulled up the price, and I'm like, dude, it's $3,000 for that little baby chip, and I'm like, I can't. I'm too much of a cheap ass to do that. So
well, and you get a really beautiful machine with the everything soldered onto the motherboard. Although I guess you can replace the battery now.
Oh, really?
Yeah.
I didn't know they could do.
Easier to replace the battery.
Oh, okay, yeah. But I know that the memory, the CPU, and the hard drive, NVMe, is all one chip on the Mac. Yeah.
Yeah, one package.
Yeah.
One package. Yeah. So, so you get a beautiful machine on that, but I was rolling there. Let me see if I can get back into my spot.
Sorry, I probably messed you up.
No, we were talking about the Steam Deck. So let me get back to that. So the one thing that you're seeing for app development, and this is actually rolls into Chromebooks and actually adoption as well. A few years ago, if you're doing wireframing, you're using Balsamiq mockups. Or I actually offered to, I had pretty good relations with the Balsamiq people. And I offered to rewrite their code to be a vector web-based solution. And because I had done that for SnapLogic, I did their design for their interface, and it's all vector-based. Pretty cool. I love doing the SVG stuff. So, and they're like, no, we're going to keep running it on Adobe Flash. And even then, Adobe Flash was on its way out, right?
Yeah.
And funny enough, that the Adobe Flash, it would run in the browser, but you could also get the desktop version, which had better performance and stuff. It used that I forget even the name of it now, but the Adobe Flash desktop version. Was what it ran on. And I
actually did Flash development back in the late 90s, and I actually built a couple websites using solely Flash, and yeah, and
I did movies using Flash too. And, so I
Yeah.
liked it actually quite a bit. It's
Yeah.
yeah, I could.
It wasn't bad to develop on. I was like,
Yeah, and I
it's
was
not
able
bad.
to remotely control thousands of computers. I mean, what the hell?
Yeah.
I'm just kidding. But
You didn't take away the security
yeah.
concerns. It was wonderful.
Oh, I actually had an interview where I talked to the guy who was the lead manager for the Adobe Flash product, and I had this great interview. Things were going really
Uh-huh.
well, and then so I'm talking to this guy, and he goes, "So you have any more questions?" And I'm like, "So you led the Bash, the Adobe development efforts?" And he's like, "Yeah." And I said, "Why'd you have so many security concerns?" Now, this is a time when what I was doing was really hot. And like I would go out for interviews, and I literally, one time in a round of interviews, I got 30 offers. Okay.
Oh, jeez.
And this guy, I did not get an offer from this guy.
You're just culling it down at that point. Oh, man.
I think I was getting too big for my britches there. That was not the question to ask if I actually wanted an offer from the company. So, yeah. So I see that Proton's been a fantastic thing, and I see Proton being the Electron of gaming. Electron. If you really want true cross-platform development and with the least amount of headaches, Proton is your way to go. I'm sorry, Electron is the way to go.
Yeah.
It's
I
got a
think
lot of
Discord and some other really popular apps are all based on Electron now.
Slack. I believe Skype now is. I even Visual Studio Code is an Electron app, or Electron style app, which is basically what you create as a web container, and then all of your like everything that you're doing in there is JavaScript and HTML, etc. JavaScript gets a bad rap from people who write Python and Go because I don't know, they're jealous. That should get some comments. But Node.js runs much. It's like 10 times faster than Python for a lot of things.
Yeah.
And it's also event-based from the core because it has to be, because it runs in the browser. So it's in a surprisingly sophisticated language that is on the surface very simple. But it's great for event-based programming and very, very fast because of all the optimization that's been done. So for people who are developing something that needs to go on a mobile phone, on Linux, on Mac, on Windows, on all different versions of them, they can compile for 15 targets, or they can write an Electron app. So the Electron app is almost like, if I were to do, I was going to do, when I did single page web applications, I proposed an app that we ended up not doing, but was actually Calendry. You may be using the Calendary.
Yeah. I know what it is. It's a little Chrome extension, I think, is what I'm using from them. Or no. I always get those crappy emails from like people like, "Hey, we want to collaborate. Click here and choose your spot."
Right.
And
so
I'm
I
like,
was actually going
okay.
through those 30 interviews. I'd actually have like 100 interviews, and I'd go to 30 on-sites. And so at that time, fighting for my schedule was a pain in the butt. And that's when I was also writing the book.
Yeah.
And so I'm like, well, why don't we do this thing? And people are like, nah, nobody's ever going to use that. Right. So now here,
Everyone uses that now.
Yeah. 7 years later, we got Calendly that seems to be just kicking butt out there.
Yeah.
Doing the very thing that I had proposed on that. So that almost was the example program in the book. In the end, we picked like this lame chat browser thing. Although you could it had avatars, you could drag them around and stuff.
Hey man, I miss IRC from the 90s and early 2000s. I loved IRC, and I was like,
You gotta love Slack, man. Slack is IRC just made graphic, and and then the Slack. I like Slack is like, get rid of email, and so you get rid of email, and then you get the same pile of junk of folders just like you had in your email. Nobody's recognized that the pile of folders is the problem. So I've got a solution for that. I actually did it back in the 90s, the late 90s, and
What'd you end up doing for the solution?
Well, so I wrote a program to manage my business, which very nearly became. I mean, we had a preliminary patent on it. It would have Microsoft would have infringed on it with their SharePoint patent. But
That's too bad. SharePoint sucks. I have had to administer it. I don't know how many times. It's like,
so
they can. Anyways, I could rant about
the key
SharePoint
to
for
it is
hours.
this: we managed our entire organization, and we do it actually for this company as well because I use the product. We manage the whole organization is on the web, and the organization is dynamically structured. So you can take departments and add them and remove them, etc., and it's infinitely recursive. So you got like your company, you got a department, you got a project, you've got a task, you got a document. It's all integrated. So there's no wiki, there's no ticket management system, there's no document store. They're all the same thing.
Mm-hmm.
Now, other companies are catching on to this, 20 years later.
Yeah.
But we had that back in '98.
Oh man.
So, and we also had this thing where you could do chat, and the chat was one-to-one organized with the company structure. So you wanted to talk about engineering software, you went to engineering software and you talked there. And it was all archived and all version. So and if you had emails, your email structure was synced to the structure of the company. So if you got a fax, when the faxes came in electronically, this was back in '98, so we still got faxes.
Hey, I work at a law firm still that I have as a client. Law firms still get faxes. I mean, it's like lawyers are stuck in the past a lot of times.
Yeah. So what you do is you take the fax, which would show up as a scan because we didn't use any paper. It was a paperless office. The fax, this is '98. You got the fax in your email. You got your voicemail in the email.
Yeah.
And you take that and you drag it and drop it into the department because those were all synced in your email as well. You just drag it and drop it in there, and boom, you could go, okay, I got this project. We were doing automotive engineering. So you could go in and say, all right, we're looking at the F-250 center console project. What's all the data associated with that project? Go to that project on the web, click a button, boom, all your emails, all your faxes, all of your documents.
That's still not done right today. And if you had that back in '98, that sounds like $1 billion project. What happened to it?
We got some funding for it, but the people that were funding it were like Enron. So we ended up becoming an Enron shell corporation accidentally. So the money we spent some time developing it. But yeah, if we were in Silicon Valley, we would have been in a lot better shape. I should have moved to Silicon Valley and looked for VC funding at the time. Although I don't know who would have, it's the Valley.
Yeah, you might have been ahead of your time there because SaaS really wasn't a thing until probably the late 2000s, I want to say, is really when people started.
The supposed meritocracy thing you see in Silicon Valley is not as much of a meritocracy as you think. It's who you know, what you know. It's kind of like Hollywood moved north in some places, and so
that's business in general, really. I mean, it's always who you know, not what you know, almost.
Right. So I don't know how all that would work, but at the time they were, we had a hell of a lot better business plan than a lot of other people that were bringing in many millions of dollars, and we didn't need that much to actually pursue it. We really made a great progress on the stuff. And we did group reviews, and we had obviously great controls because we had our own dog food. But whatever, I mean. It is what it is, and so
it just went to the deep seas. Then after it got shut down,
I used it. We almost got picked up by ValueClick, which is the number 2. We were I kept the intellectual property for it, and it almost got picked up by ValueClick. There were some groups inside of it that wanted it to replace Bugzilla, and they chose to go with SharePoint, but without understanding what we provided. I mean, there were some people that really believed in it in that company, and it came very close to getting picked up. But
having had to administer many SharePoints, I'm going to say right now they probably regret that decision.
Well, and the other funny thing is that they said, "Well, we're going to what Microsoft." You're going to be surprised by this, but what Microsoft sold was vaporware for like the first 3 years of SharePoint.
Yeah,
and I don't know if you ever used Teams, but if you've used Teams in its early days when it was actually first production, I
Yeah.
mean, what a cluster of fun that was.
Yeah.
I mean, I was writing integrations to Teams, and like I pulled it up, and I'm like, are you serious? This is from the world's largest software company. I mean, you can't punch your way out of a paper bag with this thing.
Yeah. I mean, it still has issues with like external organization members and that type of thing, to where a lot of people are like, screw it, let's just use Zoom. And that's what ends up happening a lot of times in business right now. So
yeah.
yeah.
Well, Teams, of course, they're trying to pull their lock in now, but now they've got 240 million daily users. So,
well, it comes, so that is a bit skewed because it comes preloaded in Windows 11, to where everyone just gets it automatically launched and installed as soon as you install Windows 11. It's baked into that OS.
That's not abusing your monopoly at all.
No. You remember back in the late 90s with Internet Explorer and that whole debacle? That seems like nothing compared to what's happening today. But I digress.
Yeah. It's in any event. I mean, I think it's ultimately that's what you're looking at. You've got the inertia there, and nobody gets fired for using Microsoft. And like, so now, like Teams is like people forget about Slack, etc. And Slack was just an outgrowth of IRC. But again, the problem with all of them is they're not using organizational structure to set it up. They're not tied to an organizational structure. So everybody ends up creating their own mishmash of structure, and they're all awful at it. Well, most people are awful at doing that. I mean, what you really need is you want somebody who has library science, who's setting up an organizational structure and actually thinking about doing this sort of stuff. So I have a lot of experience doing that. So we're set up really well in our company. We can go in and just click a button and say, here's all of our objectives, and here's all the tasks that we're doing that's associated with our objectives, and here's where we're at. And you click a button, here's our Gantt chart, and so. But it's a bit old school, and I don't think we're going to revive it because like there's a whole bunch of people like Monday and Asana and stuff that are getting in the area, and they're starting to actually pick up on it. Although that organizational structure thing still doesn't seem to be there. It's like they're picking.
I haven't seen anything.
Let's make this so that a stupid person can use it, and not bridging the gap on doing that. We even back in the day, back in '98, we even had a level that was designed after process was designed to accept artificial intelligence. It was near the top of the pyramid of our development pyramid. We never got to that. We got to the process level, but it was quite something. So
that's awesome. Well, Mike, do you want to take like a 5-minute break, and then when we get back, maybe do some bash scripting?
Dude, I can roll right now if you.
All right. Well, I'm going to take a break. If you want to present your desktop, and we'll get into the actual bash scripting. I'm going to hit record over here because I do want to cut this up and make like a tutorial video to kind of live on the channel after you're finished here, because there's so much knowledge that you can share when it comes to bash scripting. It was just kind of fun. I wanted to have this chat beforehand because it's just kind of fun shooting the shit, and it's so cool having that back and forth. So hopefully other people out there in chat enjoyed it. And I also
I've got the John Cusack nervous talking issue. So
Oh no, you're good.
To remind you, if I start going way off the deep end or something, it's your job to
I'll reel you back. I'm sure you're going to get in the weeds because there's going to be things that you're going to go into that I'm not even going to understand what you're doing, and I'll try and pull you back, or maybe have you clarify things when we reach there. But I think we can go to it.
I'm sorry to interrupt.
Oh no,
are you getting questions via chat as well?
Yes, we just actually had one. Why did Kubuntu choose KDE? Which I think KDE's just built on Ubuntu, and I don't know the Kubuntu team personally, but I know you interact with Kubuntu quite a bit. And
I'm actually going to be at FOSDEM tomorrow. I'll be representing Kubuntu for that. So I'll be putting on my Kubuntu community member hat, not my Kubuntu Focus hat. So it'll be focused very much on Kubuntu and what's coming up with Jammy and documentation and stuff like that. But Kubuntu, I mean, the whole point of Kubuntu from the very, very beginning, if you remember when Ubuntu came out, GNOME was kind of the underdog. The de facto preferred desktop, probably the most popular one in the world at the time, was KDE. So they had a guy named Jonathan Riddle, who was a Canonical employee. And the whole idea behind Ubuntu was to kind of hedge their bets and have an Ubuntu based with GNOME, and also have the KDE based one in case the KDE continued in popularity or maybe even took off further. As things went on, though, the GNOME got better, and most importantly, KDE got worse, much worse, for a little while. They came out with KDE, well, perhaps about a year or two. They came out with KDE 4, and it was slow, it was bloated, it was too ambitious, it was buggy, it was almost an embarrassment. And compared to KDE 3, it's just a step back. It was very opinionated at the same level that GNOME is nowadays, or actually more. And so, yeah, they just mismanaged it. They should have said, everybody keep using KDE 3 because KDE 4 isn't ready yet, and it's for bleeding edge people who want a rolling release, that kind of people. And you can switch between the two of it, but they didn't manage it well. Yep. And so the end result was that there was a flight to GNOME and then eventually Unity. And so KDE dropped in popularity. But the underlying technologies for KDE are still extremely compelling. And the slickness and unity of the desktop is second to none. And they have some of the best apps. So, and now they're very lightweight. They're lighter weight in some cases, or in a lot of cases, actually, in real use, than LXE and other lightweight desktops.
I did a memory comparison of a fresh KDE, the small install package, mind you. I think it was the Meta, or the one that didn't include all the utilities that come with KDE. And it was about equivalent to XFCE with about 500 megabytes of usage. So, and at that point, I mean, you're just splitting hairs.
And then at that time, all you got to do is run the best free nonlinear editor out there, which is KDE Live. Now compare. Okay, because that's the real use. So even when idling while running nothing, the use case is very similar. But then you take in a KDE app that has to pull in all those KDE libraries already.
Then it just
Right. So, and then versus KDE, you open it up and all you have is the app, because all the other libraries are already in there. They're on your base level for the system. So in real world usage, you actually have lower usage in KDE, especially if you're running a bunch of KDE apps, which you almost certainly are, because hey, you're going to run Krita, right? You're going to run KDE Live. You're going to run a bunch of other things that use the Qt tool set. So a lot of those libraries are just, they load them up and they stay resident because they're being used by multiple apps, and you end up with better memory usage.
Yeah, I mean, the first 500 videos on this channel was with KDE Live. So I think like the first 10 were like with some Windows-based editor. I think it was like Filmora or some crap. And then I moved to Linux and did all KDE Live for about 500 videos. And then for the last probably 100 videos or so, I moved to Final Cut because of the templates and speed with the Mac Final Cut ecosystem. But still, it's a heck of a piece of free software.
You and I need to hook up about video techniques, because I think we can learn from each other. We did a bunch of, if you look at, we do 3D model rendering for our, we've got it for, and then we do use VeraCAD for precise models of our systems. And so we take that and then we import it into Blender 3D. And then we do the rendering and animation on that. And then we do final rendering on the KDE Live or on DaVinci Resolve. And got a lot of nice, neat techniques on that.
Yeah, I'd love to see that workflow, because I think it was actually Linux Fest I went to before all the craziness in 2020. And I did an hour course, or no, it was like a 2-hour course in Blender. Because, you have like the box, and I was like, how the hell does Blender even work? Because it's such a complex piece of software. But after doing that and using Blender for a second, I was like, this is pretty amazing software, and I'm shocked more people don't use Blender. But yeah, no, I'd love to see your editing techniques
I've
and
got
how
a
to
video
streamline
editing
that.
team.
Yeah.
I told the team, I actually have 3 children. I taught them all. I've got a different level of the pipeline. So I can give you a revolving Chris Titus icon,
Yeah.
and probably get it together in a weekend.
Wow.
We'd be total kick. And if can I show this? I think just a little part of it. Let me show you a little part that I think you'll get a kick out of. So all right, so here we go, and I'm going to go to here. So I'm going to share just a window. We'll share a tab. That'll make it. One thing, if you share a tab, is that the performance for the streaming goes much better. So here's our logo. So watch this. The audio editing here is done using Audacity and KDN Live, and then mixing. And this is all done with Blender. And then we've composited in the slideshows here.
Okay.
And this is, these are selling points. We have to update this too. We have some more stuff in here. Let's see. I want to get you to some interesting stuff.
Yeah. Can you take down that audio just a little bit?
Yeah, I'm sorry about that. Yeah, I'll turn it off. Or turn it way down. There you go.
Yeah. There you go.
Okay, so
DCMA coming my way.
Okay, so check this out, and then here, look at this compositing, and watch. That's Blender there.
Okay.
And look at how photorealistic that modeling is, with the lens flares and stuff like that.
Yeah. So, I have you used Final Cut before, Mike?
No, I have not.
So, here's how silly and why everyone uses it. It's just completely crazy, but there's a little template. You pay like $300 for it, right?
Mm-hmm. Yep.
And then you just drop the image that you want, 3D modeled image, and then you just say, track this point, and as that image moves across the screen, the text will automatically reflect everything, and it's done with a click of a button. Like literally, a child could do a lot of the rendering in Final Cut. That's why a lot of times I ended up using it, because of the simplicity of it. Because
I'm sure, and sounds like a lot of times children do that.
Yeah, exactly.
My
That's why I ended up moving with it.
I mean, she does this, but she also does it like on even Android apps and that sort of thing.
Oh man, that's cool though.
Yeah, she loves that stuff. Let me show you this part. Oh, that's cool. So this is the rendering bit. So you can see here the sort of stuff you can do with the that, and then I want to show you the logo stuff. This is done again. Here's your logo.
Oh, that's cool.
Yeah, a lot of time spent on that video, which I hope shows.
Yeah, no, very cool.
Yeah, so yeah, we should spend. I mean, I think we can trade some ideas on how to, implement Blender 3D animations, how to do logos, and other stuff like that. And we have other models like that as well. I mean, if you go just over here, there's a actually I go to actually this one is different. Okay, I take that back. I'm not going to bore you with that one. I mean, it's interesting for the people out there who want to check it out on how to install apps in line. But and we'll see that actually today.
Okay.
When we talk about Bash shell scripting. But yeah, we've got some like the precision models that we do. I think could be really cool, and we could do a kick-ass Chris Titus thing and get it out there. So if you want to take the break, I guess I'll take you up on that. And we can, or I can get started. Your pick. I mean, I'm happy to keep going.
No, you go ahead and keep going. I'm just going to take a quick bathroom break,
Okay.
Do you want to just share your screen and then
Yep. Yeah. I'll get
I'll
things
let you
set up
get
here.
going so I just can watch the first start of it, just so I know that it's set up right and I don't have chat yelling at me like, I can't hear.
Yeah, you need to make sure I'm not crashing and burning too. You need
Right,
to
right, right. But as you get going, I'll take a little bio break.
Yeah, I'll see if I can avoid pulling a Roseanne Barr. Um, so here we go. We do this every day now. Okay, so I got my notes here, so I'm gonna kind of flip back and forth on these. But so what we're going to talk about today is what's called bash scripting from the outside in. Now, I was talking with Chris about this yesterday, and there's really two ways that we could do this. One way, which I've actually done a lot of presentations, like on the HTML5 Developers Conference. I've done a bunch of those in developer conferences in general. And I've very much tended to do concept-based presentations. In other words, I'd say, okay, here's a concept you need. Okay, here's an example of the concept. Here's another concept you need. Here's an example of the concept. And you know what? The problem with that is that you're trying to pull, you're kind of putting the cart before the horse. You're saying, here's the concept, and then you're showing why you need the concept. But people don't work that way. People work like they want to know why they need the concept first, or what the problem is first, and then seeing the solution. So what I propose today is I've got a whole list of concepts I want to cover, but I'd rather us look at 3 different shell scripts that we use, and then talk about the concepts as they arise as we walk through the shell script. So, sound good to you, Chris?
Sounds great.
Okay, so I'm gonna first, and then we have to also talk about, why would you use a shell script? So I'm gonna, actually, I think I already have this here, so I don't even need to reopen that. Okay, so on our system here, we have all these guided solutions, which we spend hours and hours putting these together, a lot of times just to create beautiful pictures. Some of these were easy because they're just screenshots, but let's talk about some of the things you can do with a shell script. And so there are some obvious uses. Obviously, we pretty much must code in shell script because we're doing Debian packaging, and we're using things like dev helper, et cetera. We're publishing to an apt repository, and there's a lot of requirements that we have to meet on that. And so we don't have a choice about using bash. We have to. And if we're going to be using bash for those things, then we better be good at it. And so in a vacuum, I may have written some of these applications, or it's not just me, we may have written some of these applications using something like Node.js, et cetera, or some core toolkits that are based in for KDE. But since we need to be very good at bash shell scripting, then it made sense for us to just make these relatively modest tools using bash shell scripting, so that we're focusing on one set of skills. So what you can see here is I can, let's say, click on this, and it's going to open up a shell cleaning script, which we'll take a look at today. And this is nice, being able to just go to a website, and while you're reading an article, just click on the icon. And this goes through all of our guided solutions, which are constantly updated. So you can see here, I'm bringing up this thing that purges kernels. So we're going to look at this one today because this is a relatively complex item. And I also think it's interesting for people in the crowd here, because what this will probably lead into, if everything goes to plan, is that we will have a better kernel cleanup, automated kernel cleanup for everybody that uses Ubuntu-based systems. I'll talk about the vision there, but I don't want to go any further than that right now. Another one we'll take a look at today is the power profile utility, which is actually a pretty neat little thing. Like if I'm running studio, for example, and in fact, even today, I think I'll run this on studio mode. This is a great way to manage your power usage as well as manage heat and fan noise. It goes to the problem in a different way than a number of our competitors. A number of our competitors set fan profiles and then throttle your system in order to keep the fans to a certain level. And that has certain advantages, but it has other disadvantages. We work the other way, which is we set the power profile targets and then your fan and thermals then follow. The benefit of doing that is we don't have to have a complex application that's constantly probing fans and constantly probing the CPU thermals in order to modify the throttling. Instead, we let the governor and the peak gigahertz targets do that work. And so that overhead goes away. So if you have an active fan profile, theoretically anyway, because of the increased wake states, you can actually reduce your battery life, even though it's supposed to be there to help improve it. But it is better generally at maintaining a certain volume level on your fans, because that is the driving factor as opposed to being the performance being the driving factor. And we're going to take a look. And then we'll take a look at a command line utility that does auto completion of so that you can have like and we spend a lot of time on this one. We use it all the time, which is a bookmark utility. I'll do a little quick demo on that just to keep our presentation consistent. So we have QWE, which shows a list of bookmarks. And if I want to go to our web editing page, I can just do QWE. But if I want to go underneath there, I can do a tab and see all of the directories underneath that, and then I can see directories underneath that and directories underneath that. And so I think almost everybody has a bash RC that looks like something like this. CDX equals, alias CDX equals CD bar boom X, and so on and so forth. Everybody kind of hacks us together. And we did a bunch of research on this and said, there's got to be a unified way to do this that's better than what everybody is hacking up. And this is the sort of thing that I've done for tons of organizations, lots of times. It was just stuff I would do for fun. Like I'd spend an extra 2 hours at the office doing it because I'd see that 20 or 30 people in the office are wasting time doing this every single day, and it's inefficient. So QWE is designed to be extremely efficient. So, oh yeah, I'm sorry. I told you have to keep me in line here. Are you back, by the way? Oh, okay, cool. Well, yeah, I can't see anything right now. I'm blind. Well, not that blind. So let's say I go to, like I do go to KFB all the time. This is where the development is for these scripts, and you'll see more of this. But in here, I can do a QWE, and I can do an H, and I can see that I can show my current directory. That's my current tag. If I want to see all the tags, I can do this. And so I was actually doing a demo for Chris yesterday, and I said, here, look, I created a tag called fufu, right? Let's say I don't want that tag. I can say QWE delete fufu. And now it's gone. So if I do a QWE, there we go. I could do a QWEL, which will do the list as well, and without some of that interactive stuff going on there. This is a fascinating thing because it's like we had to write our own terminal handler for doing this. So if I did say UKL, actually that's not probably good one. I'll do KF. Okay, so this, you see how I'm able to like pick and pick subdirectories and autocomplete those, and then say auto. And so basically we had to emulate the standard autocomplete, but we had to write our own autocomplete after the initial tag there. So some fun stuff there. So my plan was to show you, so I'm done here giving the demo of QWE. Hopefully some of you out there who are command line junkies find this interesting. I know that, like I said, I can't live without this now. I use it every day, constantly. Yeah, hopefully some of you command line junkies out there find the value of this. I know there's a whole bunch of different things, like a jump script that you can plug in, etc. But this actually ships with the Kubuntu Focus, and it's a default that you can add to your Bash RC, but we may actually put it in a Bash extension script so that's just immediately available for everyone without any sort of interaction you have to take on your part. So,
also, Mike, for QWE, in chat I put the kfocus Olaf for W-home repo. I found that QWE.sh extension in the tools directory under that repo. So if anybody wants to use this, if you're an Arch user or wherever, I'm sure it'll work over there as well. So you can check that out.
Yeah, anywhere that runs Bash, it's going to work fine. It may even run with ZSH or Fish. I would expect it to probably run fine with Fish. I can't speak for ZSH or KSH or anything like that, but you can go ahead and give it a shot. Oh, actually, I take that back. So it may work for Fish, but it definitely uses a lot of Bashisms, like the Bash autocomplete system. So if your shell is compatible with that and supports it, then it should be fine. If it doesn't, then you're probably out of luck. But I haven't tested it anywhere else. Our focus is Bash because Bash is our standard. It's not just our standard, it's the Debian standard. That means that even though I like those other shells, we never get past the point of saying, well, we need to do this. We need to know Bash and use Bash really well. So, fracturing our focus into 3 different shells just isn't worth it. So that's where we're at. So, okay, so those are the apps. So, Chris, now that you're back, which one do you want to see first?
Let's start with the kernel cleaner. The power profile, I think, is probably one of the coolest apps because of how you utilize the list array, I think it is, and how it uses K-dialog, which I thought was kind of interesting, and to make a GUI basically out of the Bash, also very interesting.
Right. So and there's some really cool stuff here. So I'm going to talk about them. I've got my list of things that I want to talk about here, philosophically speaking. As we get into them, I'll talk about them. So what we'll do is we'll just start from the very beginning on the power profile utility. So I'm going to scroll it down here so you can see a picture of it, so I don't have to pull it up again, although I probably will. But you can see here that, like, when you unplug the power, the default will drop to power safe. When you plug it back in, it'll go back to normal. Literally the name normal. So we should talk about this Bash shell from the outside in. So let's talk about things that we need in the outside in component. So in other words, we want to know how this thing is going to be structured and how it's going to interact with the environment. Okay, so I'm going to just open up a little point here, and we're going to say number 1 that we need root access to set power profiles. Okay, and we're going to need to set the max gigahertz, and we're going to need to set the keyboard LEDs, and we're going to need to set the governor, or if you're in Great Britain, you'd say governor. So, take your pick. And then when it works, you say, "Way to go, governor." So that's something that we need. Another thing is we need a GUI. Okay, we create a bunch of these tools, and almost all of them have a GUI. Like this video sync one is something I want to come back to that one. But the video sync GUI, the reason why I bring it up is because this thing takes days of research on how to sync video across all your attached displays and boils it down into a single click. And it's nowhere near as compelling if you've got to open up a command line and remember a command. Here you just go and find it in your menu, click a button, and boom, your video is synced across all displays at all different refresh rates. And it's just so empowering, because instead of spending 2, 3, 4 hours figuring out how to do this for yourself on NVIDIA, you've got a team that's done it and spent days doing it and figuring out all the edge cases and boiling it all down to one thing for a click. That's just wonderful. And the more people you got using it, the more time you're saving every day. So we need a GUI, okay? And it needs to be intuitive and pretty, okay? And simple, which I guess is the same as intuitive, but not exactly. So we'll go with that. The other thing we want with this, we need to be configurable, because we want to be able to add and subtract modes. And we need to be able to handle out of range modes. In other words, what happens if you use another tool to set these controls and then you open this thing up? It can't say low, because low doesn't match that. So, what do you do? Then this is where now we're doing this for thousands of people and potentially even higher. Now we have to worry about, it's got to be reliable. It needs to be, and that means it needs to be testable. And that means logic, and then also on hardware. Okay. The other thing that we want to do is we want to use standard routines. Okay. So we don't want to reinvent a whole bunch of wheels here. Right, so this is just kind of me talking off the top of my head here, but let's, okay. And then now I'm looking at my list here. We also need this to be, we need it to be a well-behaved shell script. Now you may say, what's well-behaved? Well, we need it to honor exit codes, handle errors gracefully. Sorry. We'd like it to handle signals. Although you'll see in this case, it really doesn't matter for signals. We want to honor standard error and standard out conventions. And we also want to honor any environment. Now, honoring the environment in this case means what's going on with the system. So, you've heard perhaps, if you've done application development, things like MVC. Okay, MVC is not is often thought of these days in terms of web applications, but MVC very much has its place in virtually all applications. So without digging too deep into this, let me just talk to you about how we've set this up, okay? Number one, for almost all of our apps, we have a thing called common.source, okay? And this provides common routines provides common utility routines. And it also provides I/O abstraction. Okay. Next thing that we're going to use is we're going to use KFocus Power Set. Okay. And this is going to be the back end for with three. We're going to do three things on it. One, we're going to do a mode list, which is going to be used to provide all the different modes we can show. We're going to do a mode read, okay, and then we're going to have a mode set. In other words, we want to be able to see all the power states we're going to have. I'm going to blow this up a little bit. So over here, by the way, I'm doing this on a Kubuntu Focus, but I have a 4K screen attached. That's the reason why you're seeing this like you do. Okay, so you can see that we're listing the modes. We're also reading the mode. We know that we have the low is the mode that's we're currently running in this image here. And it's also the default here for the selector. And then if I select something else, then it needs to call mode set. Okay. Nice thing about this, okay, now, oops. The nice thing about this is this must run as root. Okay. And by the way, if we're doing distro stuff, the thing about run as root is that you can use PalKit to set this up so that we don't have to bother asking the end user for the permissions. This will just do it underneath the policy kit settings. So it's a form of mandatory access control. Okay, so then we have another component. We have the KFocus Power. This is going to be the view. Okay. And actually, this would be model. Model would be here, effectively. And the view, and this is going to read from backend and present and set. Now we have a couple other things that are in play here. I'm going to move them down a little bit because, and this goes to the testing thing. We're going to have a unit test harness. And we're going to have a unit test drop script. Because we need this stuff to work always. And last night I did some documentation on this stuff and did some best practices on the script here in preparation for showing you guys this. And, some of the changes I wouldn't have made if I didn't have these test scripts in here. This gives you so much freedom to iterate so quickly with absolute or very near absolute certainty that your changes haven't broken things. Now, I do also want to talk about a little bit on this, that we have a couple things we're going to want to keep in mind here. We need to code for testing. So doing this is going to be very useful. And you can see up here, we talked about abstractions, etc. Talked about NVC obviously here. And I'll just say one. No, that's all right. Well, I don't want to spend too much time talking about what we want to do because I want us to get into the app itself soon. So, okay, I know what I wanted to add there. So we need to have linting plus bash shell pro.
Now, what is linting in Bash Pro that you're typing in there?
Bash Pro, and actually I'm misstating it here, so I'm going to pull up the name. It's a plugin for our IDE. So let me just get into here, Pro. Bash Support Pro. I always miss the support in there. So what I'm going to do here, guys, is I'll take our sketch here and I'll put it aside, and then I'm going to pull up the IDE and we're going to start. We're going to take a look at that. Actually, I'm going to do a little bit before we do that. So what I mean by a little bit before we do that, let's take a look at where we want to be. So that said, I'm going to move this out of the way, and we're going to actually fire up the application. So I'm off screen here right now, but I can actually do it right here. And let's go with power. Yeah, there's a power profile utility. Boom, there it is. Okay. I'm running in Studio, which, by the way, is a really nice blend between performance and low latency and low heat and low volume for your fans. But I can go to medium here and say, okay. And there I got the confirmation. And now I'll do power again. And now I can see that I'm on medium. That will go to normal. So I want to exercise the app a little bit in a couple of different ways here. So you can see if I run that again, that what I just picked, normal, now shows up as my default, and I'll just bring us back to Studio, okay? Now, you remember from our here that we were going to have a thing called power set, okay? So let's take a look at power set. So we're in the binary directory that has this, or I should say the executable directory that has this. And I could run kfocus power set, and I can say P. Notice what that does is that prints a list of modes for this processor. If I run this on a different machine, these values all change. If you're running, for example, the 11th generation processor, the processor has much better IPC, but it doesn't have 5.1 gigahertz as its max. It's got 4.7. So these are actually percentage calculations that are used to determine what this is per processor. We can do a kfocus power set minus R high. And high there. Oops, I have to actually run it in the, okay. And there it's reading what the current mode is. Okay, so, or modus operandi as the case may be. So if I look at power set here, and you can see that that I read this. Actually, I don't want high there. Read is there at Studio. Okay, so you can see now that these come from this list, and the fact that Studio is what's currently being used comes from this call. We have one other call on our API, okay? And that call is to set. So let's do this. We'll do this, and then what we'll do is we'll just name, let's say low. Oops, I have to use sudo here because this isn't deployed. There we go. You can't see that because you're not looking at my computer, but my computer lights, actually, let's just do this. Hey, Chris, can they see me or not?
They can see you.
Okay, so I'm gonna just take my camera and I'm gonna show what this is doing here. Let me just go to Studio again. So one of the things we do is we automatically apply a lower power level when you're on here. when you're on low power. So if I say set this to low now, you can see the keyboard LEDs. Press return, look what happens. LEDs go away. Bring it back to studio, LEDs come back. Okay. So worky. Not only that, if I say low now, and I bring the app back up, make sure that my camera's back in place there. Oh, that's pretty good. Okay, so I bring the so we're back to low. Bring the app back up. And you can see now it says low. Okay, so that's pretty cool. Let's take a look at something else. Another way that this program is run. This is the part where we ensure quality and we ensure this works properly across all of our platforms and all of our CPUs. So I'm now going to follow Chris's lead here and increase the size of this font. And I'm going to, I'll full screen this right now. Let's go over to, I'm going to use QWE again because that's what I do. And I'll go to the test directory. So now I'll just say run unit tests. And I know that my test number is 700, press return. You can't see the actual screen, but this is actually going through all of the power states and checking them. And then at the end of it, it's resetting the power state back to what it originally read. So everything passes here. Now, let's say that we decide that we want to change our power modes. Let's do that, okay? And let's see how hard that is to do. Now, I will say that before we did, we moved to the right architecture. Doing this was just a joke. It was a hack on top of a hack on top of a hack. Now, this is the correct architecture, or at least a very good architecture, because we have a model, we have a view, and we have the back end. And what this does is everything comes from the model. So if I go to the model now, I use KWE again because that's what I do. And I'm going to use KFocus power set. And there in the back end at the very top, we have a table that we use. Okay, so let's get creative here. Let's set normal to 0.8 times the processor maximum. Okay, and let's get rid of frugal and minimal. Let's bring them out here and comment them out. All right, so I hacked that together. Now we'll run the tests again like this. Okay, and notice, first of all, the number of tests dropped to 10. Yet they still worked. Why do they still work? Because we have logic in the tests to use the model as the basis for the tests themselves. It gets better. I'm now going to run KFocus power set, or KFocus power. Let's see, 189. Oh. As you do. sorry about this. This is not. This is a great example of why you do final checks before you go on presentations, but it should be pretty straightforward to fix. Your table string. Okay. Oh, well, that'll do it. Now we should be error-free. There you go. Okay, so outside of my stupidity there, which we don't want to expound on in any great detail, what you see here is, number one, our normal now has 0.8 times the maximum available gigahertz being set to it. And we've lost two things. So by going in here, I've changed a mode, I've deleted two modes, and everything still works the way we want it to. Now, as you imagine, if we have, this is a relatively tightly coupled, but properly coupled system. If you looked at how we started doing this, it was just like, okay, we're going to change it here, we're going to change it over here, we're going to change it over here. We have to like change the front end, we have to change the back end, we have to change the tests. And the problem is your cycle times go to shit. Sorry, it just takes too long to do stuff. And your errors just compound everywhere, and the value of your tests are horrible. Well, horrible compared to this. So this is an example of, and we didn't start with this, right? We started doing it kind of like we just hacked it together to get something out there so that people could have a tool like this. But eventually, again, when you have thousands of users, you don't want to have a situation where you're going to have support calls because you broke your tool. And now we can do changes like this in minutes and then push out a new package and be confident that it's going to work. All you need to do is run those tests, run a sanity check on your GUI, and you're golden. I mean, if we add back in, notice even the colors. If we add back in we'll leave some changes in here, but we'll go to that back end again, and we'll add in frugal again. We'll call it snoogle, because that's what you do. Yeah, that's snuggle. Okay, so now we have snuggle. And let's just run it again. And boom, we've got snuggle. Okay, notice how the colors are automatically picked up, right? No need to worry about that. We'll come over here, we'll cancel this. Oh, we'll put it on snuggle. What the hell? There, now we're on snuggle. So now if I do this, we should see snuggle. Oh, let me fix that one problem there.
Now Mike, now where is this script located on your GitHub? I didn't actually see it in the K-Focus GitHub.
I'd have to talk to Eric to get the location. This is in our PPA. So
okay.
It should be available via the PPA. So,
okay.
I have to look in on that. So, I mean, we started off with a GitHub, and when we were initially putting stuff together, we didn't feel like we were ready to share it with everybody yet. But at this point on the PPA, I believe it is available for everyone.
Okay, cool.
Yeah. So now there you go. Now notice it didn't say snuggle because we had this one error here, but I'll run this now. So focus power, let's set it to snuggle. Okay, now there we go. Now in the actual deployment, they wouldn't prompt me for that because we have policy kit set up there. So there you go. Okay, so a takeaway for you, Chris, when you're building your distro, you want to set up policy kits so you can have these things do without having to prompt the user at least for certain things. But what you want to do is the thing that is doing that changing, you want to have that to be a minimal script. And
Hmm.
that fits in really nice with the idea of having a model view controller.
Yeah, that way you don't have to use sudo to launch or do change a lot of these values, much like you do in like a virtual box or QEMU kind of setup
Yeah,
type deal.
yeah, and you don't want to run a GUI using super user powers. Not only do you have the problems of the fact that you're opening things up to a whole new world of security issues, but also if you run as root, then your whole like environment profile is replaced by the root environment profile potentially,
Yep.
and so it'll be styled wrong. And you've seen that perhaps when you're running, say, time shift, where you run it as root, and all of a sudden your dark background gets replaced by a white glaring background with gray
Hmm.
text on a white background. You're like, what's going on? Well, it's because you're running it as root. So yeah, so those are two reasons you don't want to run the GUI as root. So, and then again, if we go over here to test, um, and I run my unit test here, um, I could just do a reverse history here. There we go. Running my unit test now with my 12 test. Here we go. And that's it. Everything is hunky dory. I'll go back to KFB, and we will move L to goals so I don't accidentally delete that. And let's get checkout kfocus power set, because I want that to be as it was. But I am going to commit kfocus power. And I'll just say fixed stupid errors. Now, how could I caught those stupid errors up front? Well, I could have done that, and I should have done that by looking at two tools. First tool is shell check. If you're running shell scripts, if you're just running shell scripts for your own pleasure or to impress your mom, you should be running shell check on these things. Okay. It will really help you find anything that is problematic. Now here, for example, it's found that I have base name that's unused. Okay. What I normally do in that situation, because we have the same stanza that we normally use, is I'll just comment that out because it's obviously unused. But I can very easily fix that. So, I mean, why declare a variable that is not used? So the variable name is base name. So either use it or lose it. So we're losing it. The stanza is the same, so I'll just do that. I generally have a rule: if you're going to comment something out, say why you commented it out, or remove it. Don't just comment it out and leave it there. I've seen so many scripts that we've had to maintain where like half the code is commented out with absolutely no hint as to why this individual commented out. If I were to comment, I would say to do, I would say today's date. For, I would say how important this is, and then I would say warn me and how much I should consider this, but I'll just say cold and not currently used in the script. Okay, so if I'm going to keep it, I'm going to do that. If I'm not going to keep it, I'm blowing it away, because I don't want to have commented stuff in there that is undocumented why I'm doing it. If you do it this way, then you can just do a recursive grep on a directory, or use your IDE to find all your to-dos for you like that. And so that way, in your project, when you're doing a report to somebody about things that you want to do long-term, short-term, near-term, you can mine all of those with a quick script and see what's out there. Like I can just do a grep, to do star, boom, there's all my to-dos on various things. And notice how they're noted. A lot of them have exactly the format I just talked about. So, good thing to do. No pun intended. So, we've now done shell check and fixed the problem. And now we're going to take a look at another quality control tool. Now, if you use IntelliJ or any of the JetBrains tools, we ship with integration on the Kubuntu Focus to JetBrains tools out of the box. So if you with the toolkit, but Visual Code Studio is real popular as well. And I'm going to blow up this text here before Chris is forced to ask me to do so.
I was about to do that.
Yeah. Right. What I'm going to do is I'm actually going to close out this second window because we don't want that in the way. There we go. Okay, and then I'll do that. Okay, so now I'll just do this tiling over here so we can tile left or right, and I'll collapse this so hopefully we can see. Yeah, I'm gonna do it just a little bit smaller so I can see. I want to see that margin there. So, okay, and we're on K-Focus Power right now. So what you can see up here is that we have this green arrow that has a little wiggly underneath it. This is just telling what they consider typos. I don't turn this off because it's useful to make you consider what typos you don't want to use, but it doesn't stop us from publishing things. However, if I see a problem outside of that, and then we're going to have an issue. So let me do an example. Let's say I have the very professionally named foo-foo bar equals bing, bang, boom. And notice what happens up here. I've got no complaints, and that's because it's out in the global area. Now I'm going to go up here under main, and I'll just drop that same thing in here. And you'll see that I get a notification right here saying that I have a weak warning. So that is, we don't want anything published with weak warnings. By the way, when you saw me push this into a repository, this is on a different branch. Git branch. You can see that it's on a specific different branch. It's not merged into our actual mainline branch because I hadn't fully tested everything yet. In fact, you can use a commit hook to make sure that shell check passes for every shell script that you update, and you want to do that. So I can go down a rabbit hole that we won't come up for weeks if I go that way, but I have actual frameworks out there that have really extensive hooks, and that's because we were deploying to 100 million people a day JavaScript stuff, and yeah, you don't want the support cost for 100 million users. Although those were the end users, we only had a few thousand people that were using our tool to publish it. But even then, you don't want to have a few thousand people where you have a broken script. So code quality is extremely, extremely important when you're doing that. And having things like automatic hooks to prevent you from doing something stupid is a huge, huge benefit. So in any event, this is going to tell me as I'm coding what's going on. So you'll see me do some stuff in Vim, but when I'm getting hot and heavy on getting stuff done, I'm doing it all in here because it helps pick stuff up. Like I want to refactor this, and of course this is standard stuff, but I can say I want this to be done in the current file and then refactor, and then everywhere that's fixed. Just undo, we're done. Okay. Now the other thing that you can do with that is fantastic with this is you can run this as with a debugger. And I'm going to hold off on the debugger right now, but maybe later on, if somebody wants to see the debugger, I can show you how the debugger works and how you can actually have it interact with 3 scripts that are working together. I do want to mention one thing that's really important, and that's this right here. What this does is it says, if you're not sourced, then run the whole app. If you are sourced, then don't run the app. Global variables are still set, but the app isn't. And we don't import our common library. Remember our common library that I mentioned? That's done here. Okay. So
on your IDE there, Mike, can you do high contrast and maybe increase it just a couple more font points?
I can do this. I guess here, let me just split it a little bit differently here. There, that'll work. Is that better? And then let me check. Yeah, I'd actually like to have a little more high contrast. Is that better in the size of the text?
The gray background with the text, it'll artifact a lot just because the colors are so similar on the spectrum.
Yeah. They changed the one that I was using on an upgrade, and I don't know exactly what happened, but I had a higher contrast one, and then I got hosed on the upgrade. So I guess that happens. Color scheme. Oh, here we go. Let's go.
Yeah, OneDark's actually the same scheme I use for my Vim theme. So
how about that? Yeah,
that's funny.
Oh, here we go. JSON contrast. Is that better?
Yeah, I think that's a little better.
I can probably go like super, granny contrast if you want.
Nah, I think let's roll that. Let's see. Yeah, I guess it's just maybe the dark background causes that, or maybe just go with a black background.
Yeah, that's what I was thinking. I was thinking getting like the actual super super dark. Let me see. A lot of these things that are dark are like they're they're just they're not dark.
Maybe Dracula. Let's see. Maybe Dracula. I think I've used it quite a bit. No?
No, that's it.
All right.
I'm sorry. I wasn't ready for the change. High contrast. There we go.
Oh, there you go. Yeah.
Okay. Actually.
Much better. Much better.
Yeah. All right. So that'll take care of the artifacting hopefully. And I'm tempted to actually change this because this is the kind of stuff I like. So, all right. So I was mentioning that this right here only runs if it's not being sourced. So just to illustrate that fact, over here in my Vim console, what I'll do is I will say I'll say source, and then I'll say kfocus power. Watch what happens. Nothing. Well, actually, it killed my terminal, but it didn't run it. And that's on purpose. And that goes to how we mock stuff. So, the next question is, I would suggest what I do is before proceeding, we take a little bit of break and see if there's any questions from the crowd or questions from you, Chris. Or, you want to say, hey, Mike, pick up the pace, or there's a specific area you want to go to, just let me know, and then we'll cover that.
Yeah, no, you're doing good so far. I think a lot of it is just, like I said, and I kind of warned people when I started, too. I was like, this is going to be a little bit more in-depth because a lot of folks know maybe the basics of bash shell, but they won't understand what they're looking at on the screen. They may not understand what the function is. probably talk a little bit about functions, error codes, and maybe debugging a little bit more in that regard.
Okay. So, all right, let's talk about functions because I think that's actually a great thing to discuss. So what you'll see with this application, and you'll notice this when you go to pretty much any application, the more sophisticated the application, the more functions you're going to see in it. That's almost a direct correlation. When we first do our batch scripts or our bash scripts, usually it's just like we take all the commands that we did to test something out and we dump it into a file and then away we go. But as you have to use it in different environments, like this has to be used in a test environment, and it also needs to be used in a by the end user as well. So that means we have to prepare to test up front. A couple of guidelines that we have is that we've already done the MVC stuff. So we have like a command line API that we can test. And that's actually what we're testing when we're testing the code. The GUI testing here is actually not automated because it's pretty trivial. You just open it up. Does it work right? Good. Okay. That's easy to check. It's the API that we want to make sure is solid and constantly provides the results that we're looking for. We want the GUI to be as thin as possible, whereas what we want with the models, we want that to be comprehensive as possible and like Turing complete, if I can misuse that term. One of the things that you will see are exit codes, and I'm actually kind of curious as to why we had things exit the way they did. They didn't used to do that, but I did a couple of recent changes, and that's the reason why I have it on a different branch. But in any event, functions and programs are this close to each other. When you are working with a function and you're working with a program at its root level, pretty much all the same conventions apply. Give you an example. I'll actually go to I'll use the other example here, which is the K-Focus power set. So first I crucify it. Okay. It's been fully crucified. All right. So you'll see that, by the way, we document everything. So set mode FN. Okay. You notice I duck type this. Okay. And there's also a naming convention. You can pick any naming convention you want. If you don't want to upset me, or if you don't want to upset me, don't pick a naming convention where everything is plural. Nothing gets me angrier than going to somebody else's code and seeing places being a Boolean and lists being a string and array being an integer and another name that says cows, which is a associative array, right? Like, come on, help me out here, people. Tell me what I'm looking at. Pretend you're writing your code for a book and somebody actually has to read it. Look at this. Can you tell that this is a function? Hopefully. And every time you're able to remove that cognitive overhead where you're trying to figure out what the hell you're looking at from a data type standpoint, then you can focus on the logic of what's going on. And so if you write your code like you're writing it for a book and you duck type it, then you're erasing all that cognitive overhead. If you find yourself labeling every variable with an S or half of them with an S, then you're doing something wrong, in my personal opinion. And it tweaks me. So, better to say, okay, I got like mode list. That's going to be a list. Match line, that's going to be a string. Key is going to be a string. It's going to be a key string. Mode key is going to be a key string. An option line is going to be a line of text. A policy string is probably going to be a string, etc. So enough about that. So use a good, decent style and try to avoid. If you're labeling everything with an S, you're not conveying much. If everything's plural, then nothing's plural.
Somebody did ask in chat, Mike, when you called bash source earlier and you were doing that, what was the intent behind that? Like when you do a bash source, what were you trying to do with that function?
I was just showing that when I sourced it, it didn't execute the program. Instead, it just because what's happening is main FN is what's run over here. So if I go over to power here, actually here, let's figure out what's going on here. Okay, so what I'm going to do is I'm going to put a breakpoint right here. Okay, and
now what's the purpose of the breakpoint?
It's going to stop the execution of the program.
Okay.
So what's supposed to happen here, and I'll get us into the same location here. What my intention was to do was to run this, just source it. Sourcing it is going to basically import all the functions and variables into the running shell. Okay. Sourcing is how you bring in libraries in bash shell. Okay. But what I'm trying to do is pull in my library into my interactive environment, which, by the way, works just great, usually. Okay. So what I did was you can say source, or you can say dot, and then I will say kfocus power. Now, last time I did this is what surprised me. It bailed out. And I don't know why it bailed out. There, you see, it went kaput.
Uh-huh. Now, the bash source variable name there, what is that doing?
This is...
Oh, excuse me.
Okay, you'll notice that the naming scheme here follows three naming schemes, three conventions. One is all uppercase. These are environment variables and standard variables. If you're doing bash shell scripting, do not name your variables as all uppercase. You will inevitably end up overwriting somebody else's variable. And it can give you some really nasty bugs downstream. Like, let's say you overwrite a variable that doesn't matter for right now, accidentally. Then somebody comes in and edits your program or extends it, or that somebody could be you 2 weeks later and extends it and goes, oh, I need to use bash source, right? And you've corrupted bash source up higher. So now you've got this nasty situation where you're trying to figure out, why is bash source not giving me the value I want? And it's because some bozo up near the top, that would be you, or in my case, me, had overwritten it earlier because I used all uppercase for my bash variables. So don't do that.
So is it a best practice? I'm noticing a lot of your variables is starting with an underscore and then the actual variable name. I imagine that's done on purpose.
Yeah. The underscore is intended to make sure that the variables have their own unique namespace. It really doesn't matter when you're inside of a function, when you're using locals. You'll see that we're declaring all of our variables up top because variables are function scoped. So you might as well declare them up top because that's the scope for them. If you don't like it, well, some people like to declare them before the use, but I recommend you just put them at the top. They're actually like old JavaScript where they are functionally scoped. So declare them where they're scoped. So the names are uppercase, and then there's camel case, which indicate our own global variables. And then we have inside of here, we have, and this is pretty common. I think it's actually the same thing as the Google guidelines for bash, which is a snake case for local variables. So you can at a glance look at this code and say, I can look at this code right now, and I can say, okay, local, 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 global or environment or reserved, and I can tell that this is an array because it says list. I can tell that this is a Boolean because it has a do in front of it. I can tell that's a string because it says string at the end. And I can tell this is a key because it says key at the end of it. It's duck typed. So all that overhead is gone. You may not be, hopefully that this is, most people that I've worked with pick this up like that. And that whole, well, why'd you call it, or what is Francis used for? Or I'm going to spend 20 minutes doing a reverse trace to find what this variable that ends with an S means. And I can't tell you how many times I've spent 20 minutes to find out that that horses is a Boolean.
So that's funny. So where's the declaration of these variables? Is there a declaration in Bash? I don't think there is really a declared like you'd see in C programming language, right?
Well, you declare them up top, and then you then assign them below. And actually, Bash recommends that you declare them and then assign them. And actually, it's the same thing that you want to do generally for JavaScript. That's when you're using functional scope anyway.
Can you show us that declaration for these variables?
Yeah. Actually, we kind of right here.
Gotcha.
Scope. So you just declare them up top. I mean, and then it's really easy here because if I take.
So those are all declared local variables because they're all lowercase and it's declared inside of a function. Where's the global ones declared?
They're down at the bottom. Now notice what I did is I just took out one of the ones that we declared, but notice here now, I've got a weak warning. I'll go to it and it says, oh, the variable could be local. So using this Bash Pro, which is like $2.50 a month, it spots that. So it's really nice to help, like any IDE, right? To help you know, oh, okay, I should be declaring this. So what I just do is just go through, collect all the variables in the order that are declared, and then place them up at the top. And it works.
So the locals are declared at the top of the function, and the globals are declared. Where are they at exactly?
See here. You'll also see here that we code in paragraphs. A lot of this extends well beyond. I mean, I do this in all sorts of languages: Python, Perl, anything, right?
Yeah, it's just good top-down design.
So you program in paragraphs, and what we do here is see how I'm like bouncing between the beginning and the end of this.
Yeah.
And here too. So boom, boom. Or I want to see the beginning and end of a function. I'm able to do this. By the way, if I go on a side rant, this is the reason why Python drives me nuts. It's, when you got your IDE that's like using 6 cores trying to find out the end of a closure, it's about time to realize that curly braces were invented for a reason. That I like the imposed formatting stuff, but that hanging indent style is just, when you need an IDE to find a closure, you got a problem.
Yeah.
And my eyes have never gotten used to it, even though I've done a lot of professional Python programming. It drives me nuts. So that and the fact that Python still refuses to do a case statement, at least last I checked, although that may have finally been changed. But no case statement because it's not Pythonic enough. Come on, get off your high horse and just put it in there, will you please? All right.
Now, for the global declares, you have to put them at the bottom, or is it for proper Bash, just in general scripting, you'd want to do all your functions, global declares, and then call the functions at the very bottom, right?
Yeah, typically what you'll see for coding, what you want to do is you want to do declarations at the top, your simple declarations first, and more complex ones that call the simple declarations further and further down. And then what you want to do is set up your environment and then call main at the bottom.
Okay.
Now, if you're doing a stack trace, actually, the root run is called main. So main FN is kind of maybe not the best name for your root function here, but you want to do that there. And so I talked about the fact that when you're calling a function, you're basically like running another root script. So you can see over here that when we're running as a script, that main calls, the main function is called with all the arguments that were received by the script. And this is what does that. Doing this is kind of a magical expansion variable that says, okay, take all of the arguments as they were expanded and received and apply them to this function. So it's like a verbatim application of it. We could do some stuff where we're like stripping off things and stuff like that, but that's generally not a good idea. It's generally just good to create a root function that you're going to call that you want it to be the main way that your script is functioning when you're calling that script as an end user. That's what we got here. Okay, but we don't invoke that, and I'm going to explain the reason why we don't invoke that when you're running this as a source. When you're running this as a source, what happens is you're using this usually in a test script. And what you want to do in a test script is you want to load all the functions and variables, and then you want to do some messing around. You want to mock and overwrite functions that are IO functions that you want to set to have known values. You also want to import potentially your own common library and mock functions on top of those. So, and your own IO functions. So what this allows you to do is it allows you to load it up for testing, mock everything you need to mock, and then run it. And so that's how we do like the kernel cleaner, which is a fascinating study in, fascinating is maybe a strong term, but it's an interesting study in how to do that well. So we get to that, and I could talk about that. So what we were talking about before was linting and debugging, and I wasn't going to go into debugging, but because I broke this, let's figure out what's going on. So what I can do is go into my debugger. Okay, and this is debugging right now. Okay, it's debugging kernel clean right now, which I don't want. What I want to debug is the kfocus power. Okay, so now kfocus power is running. Well, or should be running. Oh, I have to hit the debug button. And now there we go. It's running this. Now I just hit a breakpoint. And it says, this is my power set executable. Okay, that looks good. It shouldn't exit because the power set executable is good. So now I can just move forward. Sorry about this tiny typing here. I can now move to the next one. And now I can move forward from that. So that looks all good. I think I know what's going on here. Why are we exiting? What one can do is go into the settings for the for this and configure it. Edit configurations, go to kfocus power, and now you can set up what you want. And let's see. I don't normally. Go ahead.
I was just telling chat, I think I'm rubbing off on you. It looks like you broke the script.
Well, I didn't break the script.
for the normal use. But what I've done is something is going wrong for sourcing the script. And one thing I can do for sourcing the script here is I like to call this the Larry Wall technique. So I'll say return 1. Okay, so notice that's not an exit, it's return. So what that'll let me to do is I'll blow things up here. I'll go to that directory, and then I'll say source kfocus power, press return. So what's happening is it is bailing out before that. So I'm going to hit this right now. I got a sense that what's going on here is associated with this. So source kfocus power. Oh, you see that it says no such directory. Oh, okay. All right. Yeah. I know what's going on here. The bottom line is this: the read link $0 is not compatible with the function sets that we have here. When you're calling it within a test script, it works. But when you're calling it from the shell, like I'm doing right now, it's not going to work because there's no $0 set. So that's $0 is the actual test harness that's being run in that environment. So it works because these things are pointing the right direction, but it's not going to work here. So not a bug, a feature. So so we don't need to go down that route any further, but I hope you get a sense of like what you can do here when you're debugging. You can actually debug. Let's see, this thing has common in it. Okay, it loads the common source here. So let's go back over to let's open up common.source. Okay, where we have a whole bunch of nice little routines here. Okay, so common.source. Let's see if something that is used by common.source. So I'm going to say import. Oh, try the right one. Import common. And I have the ones that we're using here. Oh, echo FN I'm using. Okay, so let's just go to echo FN up here at the top. This is an imported routine. All right, here's echo FN. So what I'm going to do is I'm going to actually expand that out a little bit, and then I'll put a breakpoint on here. This doesn't always work, but it frequently works. So what I've got now is I've got a breakpoint on a library that's being called. So now let's run kfocus power. All right, make sure first of all that echo FN is in here. There you go. So I'm echoing that. Okay, I'm going to do this. I'm going to say echo FN test. Now we should be able to run this kfocus power. Go, and now I have a breakpoint over in common.source. Oh.
So how I usually do it, Mike, and maybe this is just because I'm kind of a noob when it comes to bash scripting, but a lot of times I'm doing an echo directly from like a terminal that's open, and I am unfamiliar what the exit is and how you're doing the breakpoints. And maybe can you expand on the breakpoints and exit, like the exit 101 command there? Is a good example. What is that doing exactly? Because I've never used a breakpoint or an exit command in any of my bash scripts.
Okay, so the breakpoints, it's not a bash thing. That's just that's a feature of the IDE and the Bash Pro stuff. So you can actually run that, and generally you're able to like go to common source and add a breakpoint, like here in echo FN, and you can find what's going on while running it. But there seems to be certain conditions where, like I said, it doesn't always work. I've had it work sometimes, and I've had it not work sometimes. So that's one thing. That's just the breakpoint. But on the main script that you're running, breakpoints work all the time. So The exit stuff. I actually have a perhaps one of the most confusing aspects of bash shell scripting are the exit values. So what's an exit value? And remember, this is from the outside in. So from a standpoint of a well-behaved bash script, your 0 being it indicates success, and 1 indicates failure. So the exit, if you execute exit anywhere in a function, and even a function called by a function called by a function, if you declare exit, it will result in an exit condition on the root layer of the script. But there's a condition where it won't, and you need to be aware of that. So I will, if you want, I've got a deep dive ready for that.
Yeah. Let's do that, because I think we're approaching close to the end of what I see on our notes prior to.
Yeah. So here we go. Let's go to KFR, and I'm going to increase the size of this greatly so you can see it better. And I'll turn this off here. Actually, I can probably just do PWE KFR, and I want to go into best practice. There we go. All right, so we're going to do 0, 0, 100 exit codes. It'll work. Okay, and let's blow her up.
Yeah, I gotta say it's really fun being in the audience watching someone else code, because it's so much easier to look at someone as they're doing it than it is to be doing it live. As I see like little things, I'd be like, oh well, maybe this or that, and it's quite entertaining at the same time, because it's so easy to be like the armchair quarterback, and it's just a whole different thing when you're actually doing it live. It's fun to see, kind of be part of the audience and experience this. It's cool, man. I appreciate you doing this too, Mike.
Well, I love doing this stuff. I could do this. I mean, heck, I've done this for a living. This has probably been the most enjoyable part of my professional life. So, yeah. So here. I was hoping that'd be something that could be fun. So I'm having a good time. So here we go. We've got this function stuff, and what this is showing is actually how to trap things like errors, and how to handle exits, and how to handle signals. Okay, so I want to look at one thing that I think is, let's just run this, okay? So I can actually open a terminal. Well, I want to open a terminal. I'll run it right here. All right, so 0, 100 exit codes, okay? So I've implemented a stack trace here, okay? And let's look at 148 right here. So this thing says return for FN, okay? And it says, okay, the return int is 4, because that's our test. This function does a return, and its return value is 4. Okay, so now notice this. It's captured in a subshell. This is very important. Okay, this right here says take this in a subshell, and whatever the standard out is, then then capture it. Any standard error is still printed to the terminal, which is actually really important for debugging purposes. So what you want to return from functions and what you want to return from scripts are the text artifacts that you want to be captured by calling routines. You don't want debugging messages there. So use standard error for that, and use standard out for what you want captured. So what you're seeing here on this is this return value here is 4, and as expected, I echo out the captured string is the return string, and you can see it over here. The captured string is return function, and the return integer value is 4. That all makes sense. The gotcha is this one. Exit string equals exit 5fn. Okay. Here, this function is saying exit 5, but the code does not exit. Instead, what happens is the code, because it's running it in the subshell, takes that exit value and converts it into a return value and just keeps on chugging on. And so the thing that you got to be careful about is you may intend to exit from a function, but if that function is used, as it frequently is, to capture standard output, in a situation where you capture standard output, then your exit's not going to work, and your code's going to keep chugging along. And in fact, you can see that here, right over here, we did the exit function, and then line 153, 154, 155, 157, all of those run because it doesn't exit. Now, if you do want to exit, though, I'm going to add into the line here. If you want to say, okay, that should exit, I can do this. Watch this. Or if I do just that, all right, notice it's going to keep running right there. It shoots right past 153. Okay, even though it returned a non-zero exit, it returned a non-zero value, but it no longer blocks execution. But you can say or exit. Now watch what happens. And looky there, 153, it exited. Okay. Now, let me echo $? Which is the return value. What do you think that's going to be? Any bets from the peanut gallery?
Usually you get like a 15 to 20 second delay on the stream, but
yeah.
Let's see.
So, here we go. It's 5. What happens is this or says, okay, take whatever the return value is, and it's a bare exit. It says, give me whatever the last known return value is, and I'm going to exit with that. So when you know these things, then you can see that a lot of the things where you say exit 0, exit 1, exit 25, exit 101, those things oftentimes are redundant at best. It's better to just use the default value that's being passed down here. So in this case, I have a special exit code, which is 5, which means something to me. It may not mean anything to you, but it's kind of personal. But no, seriously, we can attach a meaning to exit code 5. And since this is a non-zero exit value, then it will just propagate that. So I don't need to know what the exit value is coming from this. I happen to know that it's exit value 5. But if it was exit value 26 or 92 or whatever, if there was any number, like there could be 5 different errors that are being here and 5 different codes that are being presented back. I don't need to know which one returned. All I need to know is that I'm going to say exit, and that's going to propagate that value that was returned to me upstream to the shell. So you got that smile like light bulb went on.
No, I was reading chat while I was going through here. Everybody was talking about the exit codes, so.
Oh, okay. Well, that's good. I mean, exit codes are really confusing because of that. Now, let's throw in a few other things that are really interesting on exit codes. So there is interest in this. You want to keep diving?
Yeah. Let's keep diving. Yeah.
Okay. So I have notes here, which I'll just read off. So 3 events to consider trapping. Okay, you're going to want to manage. There's exits, which we just touched on pretty good here, and then there's errors. You can trap errors, and there's interrupts. Now remember, errors are basically exits. Okay, in fact, you could say exits are errors. But remember, a lot of the routines you call are going to have their own exit status. So like if you try to CD into a directory and that CD failed, then you are going to have you're going to need to be able to handle that. Okay. So you can trap all errors. However, be careful with that. Right. One convention you could use, the bash shell, most errors are below 100 or 150. And the list of actual errors that you're going to get from bash shell routines is insane. They have things like Fred was bathing on Tuesday as with the meaning. I mean, it's insanely specific about some of the exit code values. So there's a list about what they're supposed to be, and then there's the reality, which is they're all over the place. But the end result is 0 success, 1 greater than 1 bad, below 150 reserved, above 150 or above 100, depending on how daring you feel that day, you can use for your own purposes. So let's do an example of where what we do is we handle errors, and we say, okay, you know what? Any errors over 200, I'm going to let go, but I'm going to kill my routine if the error is not, if my error is less than 200, I'm going to exit. So let's do that. All right, so I'm going to just say, hey, declare error int equals $. And I'm going to say 1 dash. Now, anybody out there want to guess why I do 1 dash? All right, so error int is going to be $, question mark. Okay, that's what I want. But notice down here I say error is 1 colon dash. There's when you a good thing to use when you're running bin bash is to use this command, set -u. Set -e has a lot of problems, but set -u is generally good. It tells you when you have unset variables. It's a good, relatively safe thing to add. Only problem is that if you do set -u and you try to get your first argument, if that first argument doesn't exist, then it will throw an error. So you don't, and it'll exit. You don't, it'll throw an error. So you don't want that. So what this will do is it won't throw that. It'll just say, okay, I'll use nothing if it's not there. Now, see, I have kill 00 or kill $ out here. So I'm going to say if, let's do this. Let's just not kill it. Say if, so we're going to do error int. And then I'm going to say if error int, let's just say if it's equal to 5 or error int, and let's quote that here. Notice how I'm quoting very, very meticulously. And then here, there's other ways to do this test, but I'm going to live with that for right now.
Now, how about the spacing towards the end of like the 4 and the single quote there? Is it required to have a space or not?
Yes.
Okay.
You need to do that. In fact, you just saw that I had a red mark there, and I'm like, what did I miss? Oh yeah, I missed a space.
Yeah.
You got to like bash is you can't have spaces during declarations, but during tests, they need the symbols to be separate. So
Gotcha.
yeah, you got to space it all out. So what I just did is I said, okay, we're going to interrupt on this. And so if I have 4 or 5 as my error, then I'm going to keep going on. So I keep on. So now when I run this, okay, notice that I made it to line 164 here. Blow this up a little bit here so we can see it better. And I will, let me tile it over here just a moment. There we go. So I have a little bit of overlap, but if I do a clear and then run that, you'll see that we made it to line 164 here. So down to line 164. So 164 was right here. We say test capture or exit is where we made that to. If I go back up to here, and yeah, let's do the. Let's just go. Let's turn that off right now. I think turning it off will do the trick. We made it to line 164. Let's just comment that out. And let's see if we get anything different. I'm not certain we're going to get something different, but I think we will. No, we didn't. Okay. Bottom line, though, is that we could actually, in this on error thing, we could actually look at the error codes and then say, okay, if I'm getting this error code, then just keep going on. Let's go to your next thing. So
now what I often find when I'm doing a lot of my scripting, and obviously I'm interacting with the shell a bit more and doing stuff specifically on the system, is I don't really use echo that much. It's just everything's really verbose. Do you have any tips for like quieting your output and just getting exactly what you need? Because what I'm seeing here is pretty minimal, and I think would be good for many people as far as probably like what's considered proper output.
Mm-hmm. So the way to manage your output that I recommend, I can think of 2 things right off the top of my head. The first thing is use log files. And if you're just debugging, a great way to do a log file is to put it into temp and just append to log file and temp. And if you forget about your log file when you're debugging, it's okay, because in temp in 10 days, it'll be deleted anyway. So as long as your log file is not, gigabytes or even megabytes in size, you should be fine. The other thing that is important is that you look at the differentiation between standard error and standard out. Let me give you a real quick example just off the top of my head, because I think that you'll see what I mean on that. I'm gonna leave that alone for right now. I'm halfway through it, but I'm gonna leave it alone. So let's do a VINT. Okay, so let's say that I had something, and actually you'll see this on a lot of stuff. So let's say a little thing that said I'm gonna do a bin bash, and let's move T to we'll call it calc. Okay, and we'll VI calc. And now that I have bin bash in here, I'll have it nice and color coded. So let's say that I say echo this, and we'll say $1:1
times 50. It's a trivial example, okay? So now let's just run calc, and we'll say 50. Oh, chmod plus x calc. Okay. Well, it's going to be that way, is it? First things first, let's put that in here.
Now, what do the dollar signs do that you're doing during that calculation?
It's expanding out the value, and that's potentially problematic there. There you go. Okay. So the dollar signs here, I don't know if I need this dollar sign here. I probably do, but I'll talk about each of them in a second. Okay, that's what I thought. Okay. So we're echoing this out. This is going to standard out, okay? Because echo by default goes to standard out. And here, the dollar sign is saying, okay, take the first argument, but if the first argument is unset, set it to 1. Okay. Now you put the quote marks around here as good practice to prevent globbing. You want this to be considered a single atom in this area. It doesn't really matter in this case, but out of habit, I just always quote this stuff. And the same thing should be done, like if you say, ls string equals quote dollar sign, and then do this and say ls, and let's say that we're using a directory, you'd say dir, okay, like that, and then close this, boom. So yes, there are lots of quotes in there, but what's going on is you're saying, I want this to, even if it includes spaces, and I want this to be able to list the directory even if the directory name includes spaces.
Yeah.
And so this is very, very safe. Whereas if you go, and you see lots of people doing this, equals dollar sign ls dollar sign dir, right? And then you get a name in, you get a space in the name for the directory, or you get extra spaces in the listing, and it just all goes to poop.
Yeah. I've seen that before, and I've actually done exactly that, and had it throw up errors and all kinds of shenanigans.
Yeah. So now let's say that we have some bugging here. So what I'm going to do is I'm going to say, okay, $2 echo, I am now going to calc. Okay, and then, by the way, notice I'm using non-interpolating quotes here. Good idea. If you don't plan to interpolate, don't put interpolating quotes.
Right. Always do a single quote in that regard.
Right. It's marginally faster, or arguably faster. I'd say marginally faster, but that doesn't really matter. What matters is what's your intent, right? Yep. So if you don't want to interpolate, don't interpolate, and it just makes it easier to read the code. Okay, so now we'll run calc again, and we'll put in 10. All right, so that's cool. Okay, but now watch what I'm going to do here. I'll say, I want to capture my output into K. Okay, so I'm going to say K equals dollar sign, and now I'm going to run calc. I actually have to run the script, but there you go. Okay. Now, echo dollar sign K. Okay. Let's do this again. Let's do it right. Put a quote around this. Dollar sign calc. We'll say 51. Quote that. Press return. Echo dollar sign K. Notice that what I captured was the meat, or the actual return value that I want. The diagnostics are left behind. They're left in standard error. Now what I can do, if I don't want to see that spewing across the screen, I can then say to dev null.
Hmm.
There you go. So now I've buried the standard out stuff, and I've captured the value, echo $K, the actual value that I wanted. Now, another clever thing that we saw yesterday is we'll do VI and calc. Okay, we could do this. We'll just do this. We're redirecting all of those to standard error.
So without anything, it goes to standard output. When you put the dollar sign or the ampersand 2, that puts it over into standard error.
Right. So we'll run this right now, and you can see here that it says we've let me clear this. We run this, and now you can see I'm now going to do calc and other stuff, and then I do a listing, and then there is a value that should be there. Yes, I assign that to K. So notice that echo $K is still what it's supposed to be. So what I've done is I've done a grouping there to send that out. But there's a problem. There's a subshell. Let's say that I have a thing where I said I'm going to go mult int equals 50. Okay, and then over in here, for some reason, I decided that I have some logic that says mult int equals 250. Okay.
Yep.
And then I'm going to go over here and say mult int, and I'm also going to make that quoted, so just for extra paranoia. Okay, so now let's just do this, and let's do echo $K again. And notice that my change did not occur. What happened? Well, we executed a subshell for doing this. What the subshell does is the subshell inherits everything from its parent. But when it pops out of the subshell, your execution frame changes, and any changes you made in the subshell get lost.
Mm-hmm.
Okay? That's actually very desirable. I'll show you the reason why. If people out there have done stuff with IFS, which is the internal field separator, right? You should never set the internal field separator, like you should never capture it and then reset it to what you captured. There's a much smarter way of doing that, okay? So let's show an example of using an internal field separator. And actually, before I get to that, let me just finish. Let's fix this problem. Now, that value is there. The difference? No subshell. The braces are grouping for redirecting errors or output, and the parentheses give you a subshell. Now, let's use a subshell for good. And here's my example. Example list, because I don't want to say examples. People. Okay, so we're going to use those highly beneficial stuff. And I'm going to say, okay, I want to echo out example. I'm going to put the work towards the future notice here, so I know I'm debugging. And now we're going to work towards the future by printing out example list, and we're going to print out all of the items in the list. And if you know anything about the lists, or the arrays actually, you'll know that that is being, that this syntax is going to do that, okay? So there we go.
Isn't there a bracket? I felt like there's a bracket in there that didn't belong.
Well, let's find out. I'm not, let's just run calc. We'll run calc. We're not going to capture it this time. And we'll say calc, and we'll say 50. And I will actually run the local calc. Okay, so there's an extra parenthesis there somehow.
Yeah. Yeah.
But you can see that my work towards the future, foo bar bing. We made a move towards the future, but we don't have what we want there. What we actually want is we want exclamation points in between there.
Mm-hmm.
So that's not the output we want. Okay, so here's my boo-boo right there. Okay, so I'll just so that we'll make it debug instead of work towards the future. And now let's use a subshelf for good. Okay, so I could say IFS internal field separator equals exclamation point. Okay, and now watch what happens here. That's the result we want. But don't do that. Okay, now here's something you're going to see a lot of in a lot of code. By the way, a lot of code that's out there, even professional level shell scripts, do not pass shell check and do a lot of the bad stuff I'm going to show you. So let's look at bad stuff that you should not be doing. Don't do this. Okay, internal field separator is a very important setting, and some of the people do this. They go old IFS equals, and I don't look down if you've ever done this before, by the way, because I've done it myself. Okay, IFS. Okay, or because this is a standard thing, you can get away with doing that. There's no.
Yeah, and then they call it, and then afterwards they set IFS back to that old IFS variable.
Right. But IFS has got all these little edge cases on doing that where it doesn't quite work right. Okay.
Yeah.
What you want to do is you want to set an execution frame where you set the IFS, and then you want to exit the execution frame so that you can get the IFS back to what it was. So, can anybody think of a mechanism that could possibly do that?
Subshell.
Yeah. Subshell. So watch this. So actually, let's do this. Okay, so I'm gonna I'll say old IFS equals $IFS. Okay, and then we'll say IFS equals old IFS. Although I'm breaking my own rules here, we should change.
Yeah, it should be all lowercase, right?
That should be camel case.
Oh yeah.
I'm gonna be, I'm gonna be true to myself here. Okay, so here we go. I'll just, this stuff right down here, we don't need to muck around with it right now because we're past that. Okay, so now we set the IFS back to that, and then we'll say debug, and we're gonna print this again. All right, so watch what happens. I no longer need a number. Okay, so there it has this, and then here it's gone back to what it was. Now, again, you can set IFS in the main body of your script without wrapping it in a subshell, but don't do that. Okay, here's the smart way to do it. Okay, do this. Join string. Subshell. Subshell capture. IFS equals exclamation point. Echo $, example list, star. There you go. So now you have bing, bang, foo, whatever, exactly you want it to be done now. We'll do it here without the IFS or the pop shell. There you go.
Very cool.
Okay. Now I'm going to show you one other thing for read that is hard fought stuff with dealing with arrays. Arrays, you know, the funny thing is people say, well, I don't code in Bash because Bash, they say a lot of things about Bash that is true about why you shouldn't use it for extremely complex or substantially complex programs. It's true. But there are some things that people say about Bash that's just plain wrong. You need to take care with your handling of your input and your output, and that doesn't matter what language you're doing it in. What differs is the syntax. Bash has the syntax to do stuff. It's got some nasty edge cases and stuff like that, but you can do it. And all languages have nasty edge cases. Some have more, some have less, but you're never going to get completely away from that. So before one criticizes a language, I think it's useful to, and I'm not a Bash defender here. I do like 15 different languages and about 6 professionally. So I don't consider myself a snob. I use PHP and Python and Perl and JavaScript quite significantly, and Bash these days on a regular basis. You can do a lot of stuff. Now, here's a great example. I want to read, and you're going to see this in some of the code here. Let's say that I have a list of, I want to do an array, I want to do a table. And actually you saw a table. In fact, what I'll do is I'll show you the table right here instead of actually typing it out. Let's go to power set. Recognize this up top here? This, my friends, is an array of arrays. Doesn't look like it. It's actually an array of strings. But if you need a multi-dimensional array, for most purposes, you can do it pretty simply. What you do is you create a delimited field like we have here, and you can see over here that I have a label, I have a power index, I have an indicator for an up ratio, a down ratio, and then the governor key, a no turbo key integer, and a keyboard LED integer. Okay. Notice how none of those are plural. Sorry. Now let's look down at what is happening here, and this is very much IFS equals. Okay. Hey, looky here, a substring. I'm sorry, a subshell. Notice how what I did was I said, okay, I want to print this out with a field separator of a pipe. And so I put it in a subshell so I didn't screw up the IFS variable. Um, let's look for another IFS. Okay, here's the syntax I wanted to share. This syntax here is reading from a line, and notice there is no semicolon after this. There's a semicolon, which is my internal field separator, as you saw above. I'm splitting those strings right now, and I'm using read minus R minus D, which is the delimiter. We don't want a delimiter, so we use an empty space. And then we put the result into a thing called bit list as opposed to bits. And that gives me all of those fields separated out that I can address individually by index 1, 2, 3, 4, 5, 6. So that's what's going on here. So 2 ways to use IFS if you're going to set it. Put it in a subshell. And by the way, some smart guy in chat's probably going to say, well, in this case, you probably didn't need to put it in a subshell because it's already in a function, which may be executing the subshell, in which case you're all right. But then once you add something below this, then you're host. So don't do that. I mean, don't run fast and loose. Just treat the IFS with respect that it deserves, or it thinks it deserves anyway. So if you ever need to reset the IFS, put it in a subshell, or if you're using it with read, you can use this syntax. Again, and this is a simple command syntax. Do not put in the semicolon there. Ironically, if you try to do this like with echo or something like that, it won't complain, but it won't work. It'll actually, so read seems to be the only command that I found where it actually, it has a special syntax where it will temporarily set this, and when it's done, it sets it back. So, and so hopefully those are really useful. So we're rolling along here, man.
Yeah, no, this is good, Mike. I would say I still want to be respectful of your time here, man. I think we got most of the things on the list here. I'm trying to think of if there's anything else. I haven't seen much from chat in what's going on. A couple people asked about interacting directly with you through chat, but I was like, sometimes it's hard to present and read chat at the same time. It's almost like a skill you have to develop over time. But yeah, I'm trying to do it, but a lot of these people do appreciate those tips, and with everything, when you get on the internet, you're going to get some critiques here and there. But I one thing I'd say to chat in this regard is, when it comes down to programming, everyone has their own unique style. And what I love about this is I get to see your style and how you do things. And while I'm not going to take 100% of what you do, if I can take 10 or 20% of what you're saying and doing, that makes me 10 or 20% more efficient when I integrate that into my own coding workflow. So it's really cool to check out how people do things in a lot of different ways of doing top-down programming or just coding in general, and you can take that and implement those into your own style to basically become better as a person and as a coder and scripting. So kind of important to not lose sight of that.
I mean, the funny thing is that when I did research on this, I wanted to follow existing style, and so actually this is consistent with the Google style guidelines in a lot of ways. The one thing that a lot of cool kids do these days that where they dislike it is like the thing where I joke about not using plurals and stuff like that, or in duck typing. Guys, I mean, like the one of the first professional programmers and one of the most esteemed ones pointed out that and I'm trying to remember his name now, but you've all heard the quote about there's two things that are hard in programming. One of them is naming things, and the other one is invalidating a cache, right? Of course, validating the cache was a lot more involved than that, and I actually understood what he meant about the invalidating the cache, but I forget the complexities involved with that off the top of my head right now. But yeah, you can make, the style here with the leading underscores and like, it's just very paranoid programming. Remove those if you don't want them. But I think the idea about duck typing and writing it so that people can read it, that's really, really important. And if you want to play loosey-goosey with your variable names and not think about them, you end up paying the price down the road. I know from my experience that while people will complain about my the fact that I'm meticulous about naming things consistently, I've never had a problem with people actually working with my code, and that's the key. I mean, the point is, I don't want to have to maintain my code. There's code that I've written 10 years ago that's still in production today. And it's because it's so well documented and so well tested and so readable. And that's the reason why they still use it. SnapLogic, Qualaroo, a bunch of other companies are using code to this day that's been written, again, oftentimes, a long time ago. And it's not because they can't read it. It's because they can maintain it and they can continue to use it.
To speak to that point directly, I mean, as I collaborate on GitHub and I get more into this aspect of things, I know I just made like the Arch Titus script and some other ones, and I'm looking at how I was doing my naming of variables, and it was just straight up caused a lot of problems. People would rename stuff, or they wouldn't understand if that was a global variable or if that was a local or if it was a system environment variable, right. And that's a problem. And I look back at that code and I'm like, after this stream, I'm going to go back to that Arch Titus. I'm going to go, okay, this is a global variable. I'm going to do underscore and camel case to dictate it as such. And then when I have those local variables, I'll do underscore and then all lowercase. I think that's a good format to follow behind. And then you're never guessing, hey, is this a system variable I'm calling? Or right. Is this, it's plain as day to pretty much everybody, especially if you've seen this type of thing. I don't review code very often. So it's really neat to kind of get this aspect of how you do things.
Yeah, and it's especially important. Well, it's especially important with anything, but any language that you're dealing with. But you need to see how you're polluting your environment. And you'll actually, if I go into presenting the, how we do the, sorry, my phone is ringing here, so I'm a little bit verklempt for the moment. If we go into the testing, you'll see how the pollution issue comes up and how it's handled and how you can code for it. So if you want to do testing, I can do that and show you how it's done. And why a lot of the stuff that we've done to this point is actually subtly or very obviously very important. So let me get my phone alarm and I'll be right back.
Yep. Yeah, that's just really cool, guys. I'm just, thanks for everybody stopping in to chat and going through it. It's just neat to see this. I just kind of wanted to go through all this real fast and kind of see and get a perspective from someone that does this professionally compared to me, which is a hobbyist. And you can see massive differences between how we do our code and just bash scripting in general. So very, very cool.
Hold on for just a second. Yes, sir. I thought that Sheila was going to pick her up. Okay, all right. Then I guess I got 15 minutes. Okay.
Yeah, right. We're pretty much wrapping up too, Mike. So you're good.
Okay,
you're good.
Good.
I love the time, and taking all the time to show us how you code is a brave thing to do, because it's like showing someone your room for the first time or your office desk. Because how you do things, everyone's always going to critique on how, well, I do it this way. It's a little bit better or faster. And it's just neat to see the different perspectives. And I just want to remind everybody of that. So, no, that's great, man.
We can go, I do have time to look over, we got about 15 minutes that I can spend showing the testing, which I think is actually perhaps the most valuable component of this for, kind of tie the whole thing together here.
Well, perfect. Let's do it. Yeah.
I did want to point out before we go forward, since we didn't get to it, you guys should check out the QWA thing if you want to use that. We're probably going to add that to the Kubuntu Focus things so that you don't have to add it to your bash RC. It'll just show up, and you can use it. But it's changed my life. I mean, I actually spent like 3 days writing this because I need to have a universal tool that always works for command line bookmarking that is bulletproof. And so there you go. So
I'll link that to chat again. I'll actually put it down in the chat for the GitHub. So if anybody wants to check out QWE, you can do that.
Yeah, you can see I use it all. I mean, I didn't initially write this. There was a guy that wrote it and he's like in Norway, and good guy. And so I'm upstreaming it to him as well. But it's just such a time saver for me. So like I set these tags. I know that I want to go into the testing thing. So boom, here I am, right? 6 letters, here I am. And if I forget anything, I can always just go boom and see everything that I have available. So useful stuff.
Very cool.
Let's just go to the tests here, and now we're gonna switch here to a different app real quick. And this is actually something that we're looking to upstream as well. And I spent like, I don't know, a half an hour with Chris yesterday. We just geeked out talking about like stuff that's going on. And we ship all of our machines with full disk encryption. And we ran into a problem pretty quickly after that where the disks were filling up. So raise your hand if you're out there and you've seen your root disk get filled up, especially if you're running encryption. And the problem is that the boot disks are not being cleaned out properly, even when you're using unintended upgrades, and especially if you're using Discover. And I won't go into all the details about that, but the bottom line is we needed to set up something that was going to allow us to clean up kernels very proactively to prevent that from occurring, because that was a support issue. Again, hundreds or thousands of people that have their systems broken because of the situation. We didn't cause it, but we got to support it and help get our customers out of that problem. So this is what we came up with. So it's part of the Focus RX subsystem. And this runs whenever an individual logs in, and it tests to see if your kernel, your boot section needs to be cleaned out. And I'm not going to get into all of the logic. Suffice to say, the logic here for what to keep and what to not keep, what to remove, is sophisticated, and it's going to get even more sophisticated. So this is very aggressively, though, it takes a look at the amount of disk space and says, hey, dude, you're coming close to having your boot disk being full. Let's get rid of these packages that we know are not recommended for running on your machine or are out of date. And so that's what this does. Okay, so that's what that does. I will not get into the logic outside of focusing on the testing component here. So now let's open up, it's called Fix Up Kernels.sh, and it is not a cheap program. It's not cheap at all. It's 500 lines of pure loving. So, what's going on here? Well, we are running through. We're building a list of packages to remove. We're building a list of packages to keep, and we're presenting them to the front end. So, it's this one does not have the MVC structure, although if I were to rewrite it today, it probably would. But you'll see that a number of things here are taking place that you saw in the other script. We're setting our global variables down here. We have this thing that says don't import common or run the main until after, unless we are being called directly, not sourced. And yeah, we have a set -u up top, which I talked about. And that's it. Okay. So now we need to test
our logic to make sure it's doing the right thing. Now, I've mentioned before that you need to abstract I/O. Okay, so let's walk through what happens with this script. Again, I'm running kernel cleaner. It's forced. It spends some time looking at the packages that are out there, and it is listing the found packages to keep, and it's listing the packages to purge. If I were to install, I'll actually do this here, sudo apt install kfocus, not kfocus, we're going to do Linux HW NARIC HWE 20.04. So that's the HWE kernel. We actually use a newer kernel. We're at 5.14. Oops, you got that in here. Let's do this. Sudo apt install Linux image tools 5.14.0-1010 OEM. There we go. So we just added a new kernel. And assuming my system is going to be anywhere near responsive here. Oh, there we go. This is an older system. The newer ones are about 30 to 50% faster. Not like this is horrible or anything like that, but the new ones just blow your mind, at least my experience. So there we go. I guess I don't need to be any more impatient than I already am. So let's do, yep, kernel cleaner. So you notice I could start this from the web interface, but I can also start it from here. And you can see now I have kernels to clean, okay? So depending upon the list of packages I have in my system, I need to be able to calculate which ones to keep and which ones to remove. And at this point, I can say, yes, I want to purge these. And it asks for my password. Then it puts the throbber on here for me. And away we go. So let's test that. So we're going to look at our test script. And I've mentioned that we have a test harness. That's called run unit test. By the way, I know that somebody on the chat is going to say, well, why aren't you using this shell test framework versus this one? And, you know, we probably will use a bash shell test framework at some point. But fundamentally, when you're writing assertions and stuff, the same kind of basics apply. We wrote a test harness, and it works for us. So once the test harness is done, everything after that is gravy. I mean, it's done. So now we can actually go to Unit D where we drop in our test scripts. And let's look at 00900 fix-up kernels, okay? So I'm gonna maximize this because we got a lot of textual information to go through and I wanted you to be able to see it. And you see that we have the same kind of basic setup here in this test script. Now it inherits a lot of environment variables and stuff and special variables that are all prefixed by T00. Okay, you can see that there. And then we have a test table, and you'll recognize this from before. The table is a collection of strings that are semicolon delimited. So how are we going to test this thing? Well, the first thing that I will talk about is that we've abstracted all I/O of that system. If you're able to say, okay, instead of actually saying read this in your body of your function, don't do that. Call a function that says read this for me. Then that function you can mock when you're doing testing. And so you can actually put a collection of answers that you're going to give into that mock. You can actually write a recorder that says, run this session. Okay, look at all the attributes that are being used to run this logic, capture them all, and then you package them up and you put them in your test script, and then you just basically have a playback. So you have a playback machine. So we're able to actually test conditions that we don't have the hardware to test for. And we can verify the logic does exactly what we want to do. So if you look at, let's just randomly pull a test 7. We're testing installed kernels that include the generic HWE, the OEM K-Focus one. This is the package that we build where we make sure the kernels are all tested for like 6 or 7 different subsystems before we send it out, because we've been burned by that before. Upstream is like release stuff that's broken things. So we now test them very quickly, but we test them with a set routine before we release those kernels. That's part of our pledge to our customers to make sure things keep working. And quite frankly, it's a lot better to do it proactively like that than to find yourself in a situation where upstream has broken stuff on you and now you got to race around to fix it. Don't get me wrong, they do a fantastic job, but mistakes happen. So we're here to mitigate the mistakes. So here we're saying, okay, these things are installed. Here's the running kernel. This is our situation. The boot is mounted on a separate partition with 139 megabytes free. And what do we expect the algorithm to do? We wrote it down. And now all this is the data that we recorded when we were doing the run. This is whether we're using a force flag, this is the answer from the user, this is the running kernel version, this is whether it's a mounted disk or not, this is the disk space available, this is maximum disk space, and these are some return values I won't bother you with. And then this is a subset of a listing of all the installed modules that are Linux based. Okay, so what does that do for us? Well, let's run it. I can run, since I have a unit test test harness, I can give it the number for the test, and it'll run just that test. And boom, there you go. I just ran 14 tests, and those 14 different scenarios test a whole bunch of different events. And they also, we can compare them with expected versus actual values. And we can make sure that they don't change over time. And we can inspect the output to make sure that it does exactly what we want it to do. And doing this test here, this test suite now is it's trivial to go and add more. So if we run into a situation that we hadn't foresaw before, then we'll add it in here. So we have conditions where we have boots not mounted on a separate partition, boot is mounted in a separate partition. You've got tons of extra disk space. You've got almost no disk space. Like over here, you can see that we have a very small boot partition, and it only has room for 2 kernels. So the minimum number of kernels is 2, and the maximum number of kernels is 2. So it's going to be very aggressive in cutting things out. Whereas over here, we've got tons of disk space, and the disk is not mounted. And so we're allowing up to 8 maximum kernels before we tackle it. So, the bottom line is this is a fantastic tool that allows us to iterate and cut our cycles times down to almost nothing. We're able to just do a change, run this. If it works, our confidence moving forward is really high, and we can keep on just jamming. We don't have to worry about structure of our program as much, because
We're no longer looking at diffs to see if things are broken. We're looking at diffs of logical tests to tell us things are broken, which is a far better metric, than seeing if somebody decided they wanted to rename Fred to Barry or something like that. Actually, I've been in environments where I've had tests like this, which have been very extensive, and I've set code changes upstream, and people freak out because like 50 files would change. And their metric for whether it's a dangerous change or not is how many files changed, not whether the regression test passed. So it tells you where they're coming from. They're not pro developers if that's their metric. But there's a lot of people that are getting paid and hired as pro developers that think like that. And you can tell how much testing they're doing. So,
hey, I get that too. Like, there's been plenty of times I get like a pull request on a GitHub project, and I'm like, well, that looks like a nuke the world commit. I have no way of testing all that. I'm out.
Right.
And I'm just like, I just got to close the request.
Right. So you need to have a testing mechanism to test that, because otherwise you miss out on fantastic improvements.
Yeah. Some of them looked amazing. I was just like, I can't take all that in.
Yeah. It's going to scare the hell out. I mean, like, you give me a way to test this. And the funny thing is, I talk with these people. I'm like, look I just ran these tests. I got 98% code coverage on this. I got, it's in these, the core functionality has all been identified, and here's all the tests. And here, and the file count that changed were like the data files that were used for the regression test, because there's been some nominal change in it, and they'd lose their freaking mind. So no, that's not how you should do it. You should be looking at the test results and going, oh yeah, that does everything it's supposed to do. And by the way, now it's 3 times faster.
Yeah.
And you just added 50 additional tests to make sure that all these edge cases are covered. So that's what you want. Mm-hmm. So let's take a look at the, so what we do on this is we use a concept of, we use a thing called in test data, where we look at the expected versus the run data. So we just ran this. Let's take a look at what happens here. I'm going to meld expect 00900 fix up kernels. And I'm going to compare that to run 00900 fix up kernels. Okay, now you're going to see all these files are the same because they met their expectations. But let's take a look at what is in here. But then I have to go pick up my daughter. So you see what's happening here? If you saw the interface, this looks awfully familiar, doesn't it? In fact, it is the interface, because we abstracted the I/O, we got 2 benefits. Number 1, this utility runs in a command line environment as well as in a graphical user interface. In fact, a lot of our tools do. And what we did is we abstracted the I/O. So it says, oh, is there a GUI available? Well, then I'll run it like that. If there's not, then we'll run it in CLI mode. So I can actually do this. Export XDG session type. I can type. Got me under pressure, man. All right. Okay, so now I'll go back to KFB, and now we're going to say fix up kernels, press return. Notice this is now, I'll do a force, and notice that this is now going to be done in a CLI mode. Okay.
Gotcha.
Another benefit of abstracting your I/O, because I can now do this. Okay. Now, the other thing that we're going to see here is so it's testing the output. So it's just all of these are the same, and you just read through this and make sure that it gets you the results you want. And then once it's locked in, it's locked in. This is the results we expect, and we're happy about it. And if someplace down the line you find out that you've got you want it to behave differently, then you just go and revalidate the output.
But this allows us to do stuff so much faster. You
That's
saw
awesome.
that, yeah, running that in real time takes like 10 times more than it does to run this. And we ran 14 tests here, 14 very thorough tests on it. So yeah, that's powerful. And I want to get to how we do that and then I have to go. So
Better hurry. Your 15 minutes are up for sure.
yeah. So here we go. Here we go. All right. So I'm going to just show you the key thing here. Okay. What's going on here is that we import, we source the file, and then we set up the environment variables. Notice I said XDG session type is TTY, which you just saw there. That says, okay, I'm going to capture the output in text. I'm not going to use the GUI. Okay. And then here is the secret sauce. Overwrite with mocks. Okay. In other words, we've loaded in the libraries, we've loaded in the source, and now when I go to overwrite with mocks, okay, when I go to that, watch what happens. We have a routine. It's a common routine. Common is generally prefixed by CM0, our common routine prefix. And I'm overwriting the prompt user. So now instead of this actually prompting the user, what I'm doing is this is the input. It prompts the user, and then it reads from our data structure up here that what I'm supposed to respond, yes or no, or Freddie or Barney. It's just, that's how it's done. And here's the uname. We actually mock uname so that we actually get back the expected string for the running kernel, and then so on and so forth. So all these functions that exist in the regular routine get strategically overwritten and mocked so that we can run this full logic test and have it consistent regardless of what platform we run it on. So there you go.
Very cool.
All right. I'm being asked to go chaperone, so I should do that now. But
all righty.
I hope you enjoyed this.
It's great, Mike.
I can talk forever. So
well, I appreciate you taking the time out of your day, coming out and just kind of showing how you do things, especially from the Bash perspective, and just kind of giving a glimpse of what it looks like in this regard. I know there's a couple things in here that I definitely have learned and definitely will implement in my Bash script. So thanks so much, Mike.
Oh yeah, you're welcome. And I still owe you the one-on-one. So
oh yeah, no, I'll hit you up, man.
All right.
All right, man.
My daughter, and hopefully she hasn't started walking yet.
All right, man.
we'll catch you on the flip side. So
all right, man. Sounds good.
I'll ask them tomorrow, by the way. So
okay.
Everybody wants to check in. All right. Cheers, mate.
All right. Later.
All right. See you, Chris.
All right, guys. Well, that was quite an experience, quite a fun seeing Mike, having him on. Thanks everybody for coming out. I know this is like a first kind of just kind of having everything in here. I know some. Oh, geez, I think I messed up some of my stuff, but ooh, actually, that one looks a little bit better. But just having everything in, kind of getting the new thing in. I love to have more professionals on, people that are professions in their certain area, because it's important to know, even though I'm a bit of a jack of all trades, there's certain people that stick in programming and do things a different way, and we can always learn from them. And I always try and think of that and look at other folks. There's two other people when it comes to programming that I think of, and they have different ways and different techniques. RWX Rob over on Twitch does a really good job of kind of breaking down some stuff. He does some other things. Other coders that, if you're looking for speed and efficiency, I know I've used or talked about Primageddon before. He's also a Twitch streamer too. But those two guys are also some other coders, and I've taken and watched their streams and taken little bits from both of them as well. And definitely from Mike, he's more of a traditional programmer, and that was kind of cool to see certain things that he does, how he did, like declared his variables and understanding exit codes and those types of things. So many cool things that you can glean from these, and I'll try and have more folks on like this, and so we can kind of glean and learn something from them. in this. I know it's a really long stream, a little over 4 hours, I think, at this point, but something that was just I wanted to do and just kind of see how it does. Just as maybe once a month or once every month or two, have somebody in like this just to kind of shake things up and maybe teach us something new and try something new itself. And I'll get better on the back and forth as well. I know that was a little bit dicey just because I don't typically do interviews or online meets. So that was my first shot at it. So hopefully I did okay. Hopefully the audio is probably the biggest thing, and the screen cap. I did take HD recording as it was coming in. Google Meeting, though, is a little bit on the pixelated side on when movement entered the frame. So, but we'll definitely be doing some more. It's amazing. And I'm glad you guys liked it, though. So many cool things. And if you want the stream afterwards, it'll be left up on the main channel. Just click my name, go to my channel page, and there'll be a section that says live streams, or just save the URL at the top of the page. The URL shouldn't change after we stop going live, and you can always revisit this whole thing. I'm going to try and go through and see if I can't pick out certain aspects of it and then maybe upload that to like Titus Tech Talk, the secondary channel. I think there's so many little different things that we could pick out from this stream because there was a lot that was covered, and I'll try and add and simplify some things down too, because one thing we kind of talked a little bit in chat while this was going on is typically the more talented and creative the individual, the harder it is for them to teach, because the stuff that comes second nature to them, things that they think just, well, everyone knows that, they might not think to say, hey, I'm entering this subroutine, or I declared this variable, because it's like, to them, a lot of times, of course I declared it there because that's just what you do. And you run into that, especially the higher the skill level you go up. So I know there's going to be parts of it where people were lost, because I'm just like you. I'm not a bash expert by any means. I just know typical top-down programming and some bash scripting, but not a whole lot. A lot of my expertise lies in like PowerShell, and I did C++ back in the 90s, so not very much in the coding experience department on mine. So a lot of that, I'm like, okay, I didn't quite get all that. So as I rewatch it and remake some little shorter videos for the secondary channel, I'll try and break down more of that and notate it, so maybe more people can absorb that knowledge. But it was great. Thanks for hanging out, Alex, Michael, everybody that popped into chat. It was fantastic. And I'll bring on more coders, and we'll have a good time, man. It'll be fun. But I'll probably reach out to some other folks and try and make this at least a monthly thing. But thanks for coming out, guys, and I'll see y'all in the next one. We'll see next week's. I got a couple things planned. I'll probably do like a community post and ask what everybody wants to see, and we'll do that for next week. Anyways, take it easy, have a fantastic weekend, and I'll see you in the next one.